Hey there everybody, how are you? Welcome to SkyTour LiveStream for tonight on the 18th of December. It's frigid and it's cold, but guess what? Right there on the screen, you can see it right there. Jupiter and Saturn are in the same field for the first time since Galileo. Now that was a long time ago, but you can see it right here. This is Jupiter right there, and there's Saturn right up there. Now, they only appear to be similarly spaced in the sky. They're actually going to get much closer, in fact, in a few minutes. Not a few minutes, but a couple of days. By the 21st, they'll be the closest. But they're in the same field of view right now. Isn't that amazing? So I think that's pretty cool. And it's going to be this way for a period of time. And I apologize for the blinking camera. I'm trying to make it stop doing that over there. But this is a really impressive time, and the pictures that we'll take tonight are just stunning. And when Jupiter and Saturn do set, because they're really close to the horizon right now, I'll show you what I mean. I'll just take a picture right now. This will be a very quick shot. You can see over here is the telescope control. This is me, hello, down here. Over here is the camera control, and then the observatory. We're peeking in on the observatory, and you can see the telescope is pointing almost to the horizon. So they're pretty close, pretty close. I want to welcome officially Space. Gina Leone, Tara is here. Cindy Murphy, Doll Eye is here. Summer Bush, how are you? And Tim F, Daisy and Zoe, and Carol Carl. You know, I have to say, you guys are wonderful. And Marianne just showed up. Hey there, Marianne. Look, Jupiter and Saturn in the same view. If I increase the brightness a little bit, you'll see Saturn a little brighter, but it'll overexpose Jupiter. But let's just take a couple of shots of that right now. I decided at the last minute to do this because at the last minute it decided it was going to be clear out. So here we go. Okay, and this is a quick shot. And let's go look at Saturn. Yeah, it's a little fuzzy right now because it's close to the horizon. And then Jupiter's still fuzzy. You can see these colors. That's because it's so close to the horizon. But you know what? It's not bad. It's not that bad. If we actually go back to our main screen here and bring up our planetarium view, we can go check out how far from the horizon these planets actually are. Here they are, and you can see that they're only 10 degrees above the horizon, which is kind of interesting because it's 10 degrees that I've designed the Arizona Observatory to be able to see down to. So we'd be able to see this from the Arizona Observatory. And by the way, I've got an update for everybody on that once we get some more people in here. Hey, Terry Groff. Hey, Isabella. Good to see you guys. And Daryl's here. Good. Daryl, if you want to join, let me know, because I did mention to you it was a last-minute stream. There was no doubt about it. It was last minute. But I have, as you can see, Saturn and Jupiter in the same field, and I just couldn't turn that down. You know? But let's go see what's going on here. Let me just get you out of here. So there they are. All right. And if we were to increase the exposure time a little bit, all right, then you can see the Galilean satellites down there around Jupiter. And Saturn, of course, is overexposed. And we're only at 50 ISO. We're actually at very, very low ISO. Okay, so if I bring that back to, say, 20 seconds and increase the ISO a little bit, the sensitivity. Okay, let's go to, say, 400. Nah, 250. And now if I take a picture, which is a 20-second shot, now we'll sit here and we'll get a picture that we sort of see here with the moons here. And we might even see Titan up here around Saturn. So it's pretty interesting. Pretty interesting. All right. So let's bring on Daryl, shall we? Okay. There we go. Let me just grab you, Daryl. Sorry about that. Oh, there you go. That's a nice shot. Yeah, we see our Galilean satellites and Saturn. Same view. I think that's great. And this is the first time these have been in the same view since the time of Galileo. I think that's pretty cool. Okay, let me go here and grab you, Daryl. Sorry about the noise. Okay, since last speaking to you a moment ago, I brought Daryl in. Hey, Daryl, how are you?
Hi, Mark. I'm good. You? Hello, everybody.
Hey, it's great that you're
Is
here.
that 3 moons there left of Jupiter?
That is. And what I'm going to do, actually, is go back to our main view here. I'm overexposing a little bit. We're actually 9 degrees above the horizon here. So we're actually quite close to the horizon.
I believe it.
Yeah. But if I drop this down a little bit, okay, and we're at 320, let's just drop the ISO instead. Go to say 100. Okay, 80 is good actually. And now we'll just drop this a little bit more. You'll see Saturn is very, very dim. And look at how bouncy the planets are. If we actually go into a magnified mode here and just do this and bring in Saturn, you can see just how irretrievably bad the atmosphere is right now. See all that bouncing? That's the atmosphere with the turbulence, and it's actually very frigid out. It's cold. Very, very cold. Yeah. Hello, Sharon Potter. Welcome to SkyTour LiveStream.
Hello, everybody.
And that's Daryl you're listening to. Daryl Mason is with us.
Did you get to see the pictures I sent of
I did. From
the
Tucson?
moon within the other night?
Yeah, those are beautiful.
They were. I thought the one from Tucson, Arizona might appeal to you.
Yeah.
And it looked much like what I saw here.
Yeah, it was beautiful.
Yeah. Folks, I told you and told you all. I hope you all got out to look at the moon with the planet pair the other night. It was just absolutely gorgeous.
It really was.
I tried to take a picture. I went over and shot from in front of a neighbor's house across the street. He has a yard full of Christmas decorations and lights, and I thought it might make a nice composition, with the moon and the planets just above it, but the picture didn't turn out, so I had to go find some online instead.
That's too bad.
Oh, well.
Hey, he's a big dog. How you doing? And Cindy Murphy. Yeah, so as you can see, right now, if I increase the time here just a little bit, the exposure time, you can see here is Jupiter and here is Saturn. Now, Saturn is many millions of miles further away than Jupiter. And
Saturn is about twice as far away as Jupiter is.
Yes. And Jupiter is the biggest planet in our solar system, and Saturn's only a little bit of a second, but not by that much. It's not really that much smaller overall, but it is smaller than Jupiter. But you can see that if this planet, which is over 80,000 miles across, is this big in the sky, well, this one is, I forget how big it is in miles, but it's actually quite much further away. We can't even see the disk of Saturn until we take a photograph of it.
Saturn's the ball of the planet on Saturn is smaller in diameter than Jupiter, but the rings are a fair bit bigger than Jupiter.
Yes.
But when you look at the two right now, Jupiter is about 500 million miles away, and Saturn is right about 1 billion miles away, or twice as far.
Yeah, and if you look at the way the rings are here, if you were to take the rings and go measure across the rings here, you would say to yourself, well, wait, those rings they'll fit inside of Saturn. I'm sorry, they'll fit inside of Jupiter. And you'd be right for the visible rings that we can see, but there's actually gossamer rings that are actually out beyond what we see with our eye. So the total ring diameter is bigger than what you see with your eye. And there's rings inside of Saturn toward the planet even closer. But, don't get used to seeing the rings around Saturn because they are evaporating. No, we won't have them disappear in our lifetimes or in the lifetimes of 1,000 more lifetimes out beyond us, but they are evaporating. And that's something that is a function of the evolution of Saturn and almost any ringed planet. The rings kind of give us an idea about where the planet is in its evolution, because we know that the rings will not last around the planet because they were made in a very turbulent way. So they're going to end up evaporating over time. So Saturn's rings do rain out into the upper atmosphere of the planet over time. But this is beautiful, isn't it?
It is. You will see the rings of Saturn vanish for a time, a few years from now.
That's true.
But then they will come right back.
That is true.
When Saturn moves into, I guess it'd be an equinox on Saturn, when it's the orbital plane. Saturn is tilted just like the Earth is on its axis. So we see above the rings the most during Saturn's solstices. And then during Saturn's equinox, the rings are pretty much edge on and they disappear for a while. But then Saturn moves toward its other solstice and we see the rings open up again, but we're looking at the other side at that time.
Yeah. Now you want to hear a little
that
interesting...
That happens twice in orbit.
That's exactly right. And that's...
about 30 years.
Yeah. So you can see it twice in your lifetime.
Uh-huh.
Typically. So here's a little interesting tidbit. My oldest son's birthday is December 21st, the winter solstice. That's also the date that these planets are going to be closest together in the sky. And the last time that was actually true was when Galileo was alive. And it just so happens that my son's middle name is Galileo. So it's a lot of convergences there, you see. I didn't plan it that way, though. And that wasn't the play on words when I said planet.
Huh.
Right. So how is everybody? What's that?
My birthday is on the 23rd.
Okay. What are we getting you for your birthday?
I'm not named after Galileo.
Well, I named my boys, Gabriel Galileo and Hunter Orion. And the Orion actually came... I wanted his name to be Orion. But my niece came in the house after I said I want his name to be Orion, and she hadn't heard me say that. She walked in and said, "Uncle Mark, you got to name your kid Hunter." I went, "Hunter Orion." You win.
That's pretty good.
Yeah, you win.
An old friend of mine named one of his... he and his wife had twin sons, and he named one of them Avery Orion.
Oh, what a good name.
But Hunter Orion is certainly... I mean, since Orion's a hunter, of course, well,
yeah.
There you go.
I agree. That's a really good... that's a good naming, though. I like Avery Orion. That's nice. I just thought the convergence of her saying Hunter and the fact that his name was, already Orion was pretty cool.
Oh, yeah.
Now, we're going to do the following. We're going to watch the planets actually set, and then we will move on to other things in the sky. Because by that time, we should have some other action on the other side of the sky. And we'll do that. But I wanted to make sure that we could see the planets and see everything going on here. But keep in mind that we are suffering in the seeing because we are looking through a lot of atmosphere around the edge of the planet there toward those planets, which are millions and millions and millions of miles away. And the atmosphere, seeing through much more atmosphere, is going to make this look turbulent. And that's exactly what we see. Okay, and I think I showed you. But if I were to just bring this magnifying system up and bring Saturn down into that loop, you can watch it jump around. Jump around. Everybody jump around. There it goes. That's Saturn playing games. And nothing I can do is going to sharpen that up, because the atmosphere is making it really turbulent. You can see those cells. In fact, if you look carefully, you can actually see these little turbulent cells inside of Saturn's image. Now, if this is what our sky was, if our sky was really had a much, much thicker atmosphere, then that's how we would see stars all the time, even when they're overhead. And that would be terrible. We'd lose the stars almost entirely when it got near the horizon. So there might be a small window of opportunity to view the stars, but that wouldn't be a good thing. What the heck happened there?
Holy cow.
Yeah, how about that?
On the good side, I mean, that's the same thing that causes twinkling of the stars.
Yes.
And if you go out and watch Sirius rising early in the evening now, just to the lower left of Orion a little bit, Sirius always is a beautiful twinkling star. It's the brightest star in the sky, of course, and it flashes blue and red and all sorts of colors, and it looks like a Christmas ornament.
It does. It does indeed. By the way, the big dog is actually Liz. Hello, Liz. Nice to see you here. I don't think that you've been here before, but welcome to SkyTour LiveStream. All are welcome. Everyone's welcome. So I think let me just see where we are in the sky, where they're located right now. They are now, okay, this is our planetarium view. They're 8 degrees above the horizon right now. 8 degrees. You can see the 8 right here. See? 8 degrees above the horizon. And so at 8 degrees above the horizon, it's actually a fairly clear night. This night was not supposed to be clear. We had 15 inches of snow yesterday. And today, we have clear skies. It usually happens that way after a blizzard comes through, and it was vicious. The winds were 30, 40 miles an hour. I had drifts inside my garage through the brand new garage doors. They can't run around the edges. And you know what that meant for the telescope? I actually had snow inside the observatory in drifts. And I had to clean it out. And the observatory was sealed up pretty tight. It's just that those little tiny seams allowed a little bit of snow to come through all night and all day. And it just built up. I had to cover the computers. I had to cover the telescope. I had to make sure that it was all clean. Luckily, I won't have that problem in Arizona. And now that we've got a few people here, I just want to let everybody know the telescope that we're looking through tonight is actually going to be heading to Arizona on December 27th, which is just 10 days, 9 days. So, and it'll be there on the 29th. And it's being driven out by another person that you all know and love. It's being driven out by Keith from P&K Space Imaging. Keith has a trucking company, and he has agreed to cart this system with all of its gear out there. And he'll need to see it anyway because it is P&K that are going to be sharing the observatory with us out there. They're going to put a telescope in the observatory, and there'll be a third pier going in, and that's going to be for our wide field instrument that we're going to be putting in. And I mentioned to Daryl, I might have told you guys, it's going to be a 5-inch refractor that's going to be a wide field called a rich field refractor. And some of the amazing views that we have, we've gotten from that 5-inch refractor. And Bonnie Stanley is out there. Hey, how are you? I'm not in Phoenix at the moment. I'm supposed to go on January 5th after all this equipment gets out there. We had to just deal with 15 inches of snow, Bonnie. So I was like, ugh, So it's crazy. But at least we have 2 planets in the same view. We got Jupiter here and I was going to say Orion and Saturn up here. It's amazing to have this happen like this. But look at how they're dancing. They're just dancing from being so low in the sky.
Mark, could I ask a favor?
You may.
Would it be possible for you to post that picture from Tucson I sent you?
Oh, that's in the Skype, I believe.
Yes.
I might be able to get that. Yes, let me just go down here and find you. There you are. You're here and there. And maybe go into this. And I think this might be it.
That's it.
Yeah, that's a beautiful photo. Let's...
Tara and Marianne might like it too, since it's an Arizona shot.
Yeah, let me see. Let me see where I can find it. There it is. That's the shot right there. It's a little bigger than what it should be, but... See, that's the shot that was taken.
That's a cactus.
That is a cactus.
Right, that's a saguaro.
That is right there, yeah. Yeah, so you can see here there's Jupiter and there's Saturn, and then the moon. Now the moon is now over here, actually over here, and Jupiter and Saturn are even closer than in this photo. So it's really pretty. That was a really nice photo that you found us.
It was really a beautiful view live.
Yeah, I bet.
I watched it till it... the moon dropped into the trees over the neighbors about 6 my time, and
okay.
It sure was a beautiful view, though.
Wow. Yeah, it was.
The dark side of the moon was glowing with reflected Earth light, like you could see in that picture, and it just couldn't ask for a nicer pic.
Yeah.
Nicer view.
Yeah, and yes, I got a haircut, believe it or not, Bonnie. She asked if I got a haircut. Is it true? She asked, is it true there's a star lineup on 1221 that hasn't happened in hundreds of years? Yes, Bonnie, this is it. It's not stars, it's planets. It's Jupiter here in this view, and it is not just Jupiter, but it's also Saturn, which is right here. Okay, and right now they're very low to the horizon. Okay, and if we look at our, let me just get rid of the dome cam for now. We don't need that on at the moment. But if we look here, you see Jupiter and Saturn are now 7 degrees above the horizon. The horizon being right here. Now, in this view, okay, I actually, let me just do the following. I'm going to change our landscape to this one. Okay, so now what we're seeing is this is our landscape. Okay, so this is over here is the dome for SkyTour LiveStream right there. You can't really see that too well, but it's there. And the moon is up there, and Jupiter and Saturn are now going down into the trees. So they're actually pretty close to becoming invisible. They're going to start to go away on us, but there they are for now, and we'll just keep on hanging on. And when they do finally go, we'll move on to other things. Hey there, one man. How are you?
Mark,
Marco?
I'm going to leave once Jupiter and Saturn are gone. Are you going to be carrying on for a while tonight?
Yeah, I'll probably be. You probably. I know this was spur of the moment. I told you probably like 10 minutes before I actually decided to do this.
Yeah.
So I know you have dinner and everything to worry about, and so do I. I'm not going to be able to get to dinner until I finish the stream, because my mind is, full of astronomy tonight, Yeah. And another news, I got the spectrometer working, and I talked to the author of the software that controls the spectrometer, and I have a real good feel now for being able to do things like look at Jupiter with the spectrometer with the next telescope we're going to put on this mount, and be able to see what Jupiter's atmosphere is made of. All right, we'll be able to do that, and I found some really, really cool ways to do that and to visualize it. So it's really cool, and but you know what? That's gonna be one of those special nights where you learn about spectra and how we understand what a star is made of. We'll be able to look at starlight and take it apart, figure out exactly what the star is made of. And there's a star I wish I could show you, but it's in the southern hemisphere. We've been searching for the star that is our own twin for our sun. And the reason we've been doing that is because our sun was born in a cluster, like most stars. And the stars finally, they moved apart from each other over time as the gravitational interactions whipped them away from each other. And then they started orbiting the galaxy and took up, orbits of their own. Well, our sun was part of a cluster at one point, and we've always wanted to figure out as astronomers, where is our birthplace? Where did our sun start? Where was it born? And to find that, we have to find things like other stars that are exactly like the sun. Because if it was born in a cloud of dust and elements in our periodic table that are just like our own, that we see in our sun, then other stars that were born in the same cloud will have not just some of the elements, but exactly the same elements in exactly the same combination and amounts. And so we were on a mission for many years as astronomers to try and find our twin, at least a twin. And up until, was it 2 years ago? Up until about a year and a half ago, I think, we didn't have any success. And then suddenly, down in the southern hemisphere, an analysis of one particular star showed that this star, which was not that terribly far away from us, was exactly like the sun in every respect. Spectral type, composition. This was truly a sibling, truly where our star was born at one point with that star. And so they migrated away from each other over time. But where was that original birthplace? We have to go backwards 4.6 billion years to find that out. And that's the problem. In a changing, that's like seeing passenger jets flying over your house, right? When they don't leave contrails, okay? And they're all traveling in different directions. And you say, where did they all cross? You'd have to try and work backwards, right? With jets, it's easy because they go in a straight line. But stars aren't going in a straight line. They're going in curves. And they're being gravitationally moved by other stars as they pass by. If this is a star and this is a star, if this star goes by, it's going to go whoop and get pulled up by this star's gravity. And this one's going to get pulled down. So they're not just going to pass each other. They're going to do this. And now they're on different paths. How many stars do you think we passed in 4.6 billion years? A lot. Same as our sibling, okay? Similar. But we were thrown apart by all of those many interactions. But how could we possibly reverse engineer all those many interactions? It's literally impossible at this point to do that, because we don't have a crystal ball. We can't look back in time. But if we could figure out where in the galaxy we were born, maybe it's possible that over 4.6 billion years, there is a location in our galaxy where this particular combination of elements and dust and materials are still there. And if that's true, maybe that location is where we were originally born. And then as we migrated away from gravitational interactions with all the members that were born there, we could look back and say, aha, we were born here. It's really the question of the century, a question of the ages, actually. Where was the sun born? Because all the elements in that planet there, Saturn, and all the elements in that planet there, Jupiter, they all came from other stars. Just like everything you're made of, and you, and you, and you, and you too, Francis Palmer. Welcome. All right. Those elements were all at one time made in the hearts of stars. Hello, Monique Coleman. And one man, I think I said hi to you. So it's really an interesting way to look at the universe. Is that we were all born of the universe, but born from the most violent of reactions. We could have come from a supernova. We could have come from a nova. We could have come from a planetary nebula, which was a star that sloughed off and shed its outer layers as it got older, and bloated up into a red giant. I mean, we could have had all that happen, and all of the material that we're made of could have come from all of those different things from a lot of different locations in the universe, in our galaxy anyway. So it's really quite a fascinating topic. Jupiter and Saturn are really dancing now, Daryl. Look at that. Yeah, let me...
Mark, if you'll excuse me, I need to run for now. I'll try to swing by later. Will you be on the same stream or start a new stream if you're on later?
Oh, no, I'm going to stay going.
Okay.
If not, I'll cut it. But don't rush back, Daryl. You enjoy dinner. Have a good dinner. This was a stream that came out of the blue, or out of the black now, as we can see. So thanks for coming. I know it was last minute, but I'm really, really happy to actually be able to show you that we have both of them in the same field.
Oh, yeah.
Pretty cool.
And folks, keep watching. They're going to get closer and closer. They're
right.
Closest on the 21st. And this is, well, I say this is the sort of thing people used to measure their lives by, okay?
Mm-hmm.
A lot of people don't bother looking anymore, but it's really literally a once-in-a-lifetime thing, and go out and take a look if your weather's clear.
Yeah.
You may just be amazed.
And you know something, Daryl? They are looking, and in part that's because of you, and because of me, because we're doing this. So people are out there looking. So those folks, many of them in this group here, have you to thank for the fact that they went out and looked. So I think that you done good, man.
Well, here's to us.
Exactly.
All right, y'all take care, and maybe I'll catch up with you later.
Okay, we'll see you later,
All
Daryl.
right.
Thanks for dropping by.
Thanks a lot. Bye-bye.
Bye. So there you go. I mean, that is really something. And you can, I'm right to the bitter end here, right? I'm waiting for these planets to set. And let me just show you one more thing. Let me bring this up. For those that have been watching, let me... okay, yeah. All right. We're actually... Jupiter and Saturn now are at an altitude of 5 degrees above the horizon now. 5 degrees. That's pretty small. That's a real... if you want to know how much that is, that's basically... if you take your hand can be like a measure. This is 10 degrees. So say 2.5 fingers is 5 degrees, and you put them like this, and that's how far they are above the horizon. And we're actually looking at them. You'll notice Saturn's actually a little bit red. I want to increase the exposure here just so you can see that. All right. We'll just take a quick photo. It's not going to be a good photo because it's too close to the horizon to really be seen very well. But it's actually look at that. There's Saturn. Look how red it is. Yes, sirree. And now there's Saturn and Jupiter together, and it's a lousy photo. Yeah, it's just unfortunate, but that's okay, because without the atmosphere we would all not be able to breathe, so we're okay. So there it is. Yeah, Jupiter, Saturn together. We can't see the detail on Jupiter. Oh, I do want to show you something though. We could actually slip up to the moon and check out the moon as well, if you'd like to do that. So we can do that momentarily. I just want to wait for Jupiter and Saturn to disappear. People have been coming to see this particular aspect of it, and I think that's actually a good aspect. All right, let's see. Well, there's a few of you out there now. So yeah, so we'll head up to the moon here in a moment, but I just want to make sure that everybody gets a chance to see the two. That's pretty close in the sky. That's really close. And it's going to get even closer. Even closer. By the 21st, Jupiter is going to be even closer to Saturn, and it's going to be so close that you might be forgiven for thinking you were looking at one planet in the sky, because it's going to be less than the width of your pinky at arm's length in the sky. So, hey there, Q, what's up? And you were talking about my hair, well, or lack of. I actually got a haircut, so that's why it looks this way. So anyway, I think that we should head up to the moon here in a bit. The moon's really dramatic tonight, incidentally, and I've actually color corrected the view here. You can see right down here, and I know it won't make sense too much, but it says, you know, I'm at 7800K with a correction for B7 and G 2.2. That doesn't mean much to anyone who's not a photographer, but all suffice it to say is I've shifted the colors such and the camera's sensors such that even though we're shooting through special filters, the image is going to look right to us with the right colors. And that was something that we always noticed, that the colors were shifted toward the blue. Well, I've changed that, so now the colors are shifted back toward where they belong. So that's pretty cool. And I'm glad we could do that. Let's see. I'm reading a comment from Amanda here. Okay. So we miss Amanda as well, but we are now actually in a position where when we get to Arizona, this stream is going to really take on a different life, because we're going to have to start streaming later in the evening, because Arizona, if I were to stay in Connecticut, which I'm not planning on it, but I'd have to start the stream like 10 p.m. here, and that's for the winter time, so that we could have like an 8 p.m. startup in the winter and a 7 p.m. startup in the summer, which it wouldn't even be dark yet. So we'd have to start almost at midnight here. So that's why I'm gonna be going out there and getting out there and staying out there and living out there, because I love it out there. If you've never been to Arizona, could we show you pictures, or could we show you pictures? Marianne Robb lives in Arizona. Tara lives in Arizona. Tara's the one that did our door, if you remember. We have a beautiful door on the SkyTour LiveStream West Observatory now. And that door is just unbelievable. You know, unbelievable. It looks really, really beautiful. And I would like to... Oh, well, first of all, let me give you an example of the colors in Arizona, okay? Let me see if this will show up. Let me just go here. Okay, so check this out. I took that photo from the observatory site. Now, you talk about a beautiful sunset. That's looking obviously toward the west as the sun was setting. That's right, Terry. They don't ever change their clocks, which is another good thing. So sometimes they're 2 hours behind here, and sometimes 3. You know. So yeah, so there is a beautiful photo of the sunset out there. Saturn and Jupiter are bouncing even more. Holy cow! Look at them go. And then the night sky out there is just it's so stunning. It's very, very hard to even actually hard to understand. But I'm going to show you a picture that shows you what I mean by all this. Okay. Now, this photo I'm about to show you. Okay. This one, you have to really look at it and to try and figure out what's going on there. All right. Check this out. Here's the Milky Way. But what's this red down here? You know what that is? That's sunset. At sunset, the Milky Way is this bright. How about that? How about that? These are two little lights from distant folks. But look at this. Sunset. Yeah. And then you might notice this. There's like a red kind of glow horizontally through the view here. That's something called sky glow. It's not high altitude clouds. It's sky glow. It's the glow of nitrogen atoms after the sun sets. They continue to glow, and you'll see green as well with oxygen atoms as well. So it's really, really amazing. Yeah. And Randy Harris is here, who also lives in Arizona. Yeah. So we've got some really cool sights. There's Saturn. It's still Saturn up there, right there. Let's increase the sensitivity just a bit. Yeah. And you'll notice now that, you'll see now that we're starting to actually, you can't really see too well there, but I don't think a photo would do it justice, but let's try it. I'll do a 15-second photo at 500 ISO and see what we get. You'll see that it's actually going to be quite an interesting view. You might get some red of the dome because I think that the telescope is now low enough so that the lower part of the dome is affecting it. So we'll see. Yeah, see? Yep. So yeah, now the telescope is down low enough so that the lower lip of the dome is actually interfering with the telescope now. And you see there's little shadows you see going through there. You know what those are? Trees. So we're seeing this through trees. I think it's just beautiful. But what I'll do is I will bring up our planetarium here and do the following. I'm going to say, let's go over and find the moon. So say goodbye to Jupiter and Saturn for now. And we'll go find the moon. You'll see them zip away now. And there they go. And the telescope will be... Okay, and that's... The way the telescope finds things is it goes to a star first, and from there it hops to the proper location. So this should go zipping down, and the moon should come in. And there we are. Now this is a really beautiful image of the moon. I'll tell you why. Because it's bright enough so that we can actually see stars in the same view, like this one. Okay? And we see the side of the moon here that is not yet lit. However, we see it. It is lit. So what are we looking at? We're actually looking at Earth shine. The reflection of the blue Earth on the moon is what we're seeing here. Is that not beautiful? I mean, that's just beautiful. That's a beautiful picture in and of itself. Oh, Farva's back. Hey, man, I haven't seen you for a while. Yeah, we missed you, man. We missed you. So good to see you. So yeah, so let's just take a picture of the moon here with this overexposure so you can actually watch. Let me do it this way. Let's drop the exposure down to something less. Let's say 1.3 seconds, but increase the ISO to get that back. That's going to make it a little more noisy. But you'll notice up here, you see that spot right there? That's sort of white. Well, the Earth shine is already illuminating this crater called Aristarchus. And that's Aristarchus up there. It's the brightest spot on the moon. So here we go. Let's just take a quick shot of this. All right. And there we go. Look at that. It almost looks like a painting, doesn't it? Let me actually show it to you in a way that looks like a painting. Here we go. Look at that. So that's a beautiful shot of the moon taken this way. Now we are color corrected as well. Hey, Adam Lorver, how are you? And what I'll do now, and this is the live view here. Let's actually take this live view Alright, and what I'll do is I'm going to reduce the ISO. I'll bring it down to 50. And you'll notice the star up there in the upper right hand corner, which you cannot see, is going to get even less pronounced. And now what we'll do is drop the settings here down. And now let's take a photo of this. Ah, look at that. What a beautiful moon. Look at that. Yeah, so the moon looks pretty. And the moon itself is actually getting lower in the sky too, so it's going to get progressively worse and worse seeing as we go. But right now it's not that. Yeah, it was much better earlier. I'll show you some photos I took earlier of the moon because I wanted you to see if I couldn't show you then. So here was the moon earlier, that same region. Look at that. See that? It was much higher in the sky and we had a much sharper view of it. And now, because it's down near the horizon now, the view we get is this one here. But I'm going to try and actually focus just in case, because the focus does go off on occasion. But you can see if we look, okay, that's the if we look actually in the image here, let me just bring us up here. We'll also go to this guy. All right, now if you look here, you'll notice that the moon is dancing quite a lot in here. Can you see that? And let's bring us into a very yeah, I'm right here. Yeah, okay, thank you. If we look and bring it over, there we go. Look at that. Talk about dancing bear, huh? I mean, it's just dancing away. It looks like I'm dancing away over here too. Okay, so okay, let me just get rid of my camera right now. Okay, so here we see the moon dancing like it is. It was very still before, you know, and it wasn't that bad earlier. And this is a magnified view. But we can try to see if focus might help us. Just a little bit. Yeah, that's a little bit sharper. But that's about all we're going to get out of it because of it's set up to the horizon. It's actually lower to the horizon. Farva, thanks, man. Thank you very much. Yeah. You know what's funny? My favorite view, when we look at the moon, my favorite view, believe it or not, is when we do this and we actually see the other side of the moon. And the reason is because when you look at this, all right, this, now if there was a meteor impact on this side of the moon, you would see it as a spot. There would be a flash. Now, how do I know that? Because looking at this moon right about here during the lunar eclipse last January, I think 2 Januaries ago, we actually saw a bright flash right about here. And that bright flash was a meteor hitting the moon. And what's odd is I think I just saw one right there. So I'm not sure whether something actually struck the moon or I got a errant pixel. But man, it's incredible. Yeah. So we'll stare at the moon for a while. The moon's fun to look at. And when it gets down in front of the trees, we actually see quite a difference too. So what I'm doing, okay, and why I'm doing this is because I would like to just have a record of a potential meteorite strike on this side. So that's why we're doing this. We're gonna make it even a little bit brighter. That's about where we go right there. Okay, so if we watch this side, if there's gonna be a meteor strike, then we'll see it. Now I'm gonna go move the dome a little bit, and I will be back. But I will leave the music up and running. If you got questions, put them in the chat, and I will check them up. I'll check them up with you, and I'll answer them. So I will be back in just a few minutes, and so don't worry, I haven't gone away. We're looking at the moon tonight, but it's overexposed on purpose. You can see a star up there, right here. Okay, and that's in the field too. So just keep watching the dark side and look to see if you see any flashes of light. If you do see any, make a note of them. Stick it in the chat. You'll notice the time at the top here. Take that time and mark it down and put it in the chat. Right. Hey, and P&K Space Imaging is here. Hey, Keith. So, Keith, what's going on in here is we looked at Jupiter and Saturn in the same field of view. They were about as far apart as the width of the moon, maybe a little less. And by Monday, they'll be together. And Marianne needs to talk to you, Keith. Since you're driving out telescope gear from here to there, I told folks that you are helping to get SkyTour LiveStream West up and running by bringing out the equipment. And I think that's fantastic. You know, you are amazing. And yes, you're not behaved many times, but that's okay. It's all right, man. Everybody loves you anyway. Okay, I was just saying that I have to go out and move the dome a little bit, but I will be back. So you guys, you hang out, enjoy the music, and I shall return in just a bit. So I'll be right back. And Farva strikes again. Thank you, Farva. Hey, welcome back. Well, I guess I'm the one coming back, right? How are you guys? Everything still good? Oh, we still have our moon. Anybody see anything strike the moon while we were away? I see Keith is still here. Keith, did you want to come on? Yeah, that didn't come out quite right, Keith. Fine. Wow, Adam, thank you so much. And Farva, you guys, thank you. We're on a meteor watch here with the moon for a while. I think earlier I saw a flash right about here. But we'll have to verify it, look in the stream, and then figure out if the Spanish Lunar Sentinel Society has seen something as well. Yeah, if you had warning, I know. But it's okay, Keith. I know it was a stream out of nowhere, that's right, because I happened to get clear skies, number one, and number two, I drove the telescope over to Jupiter and Saturn, and guess what? They were both in the same field as I thought. So I quickly raced together to put up a stream. I didn't even eat dinner. You know? That's okay with me. Had a problem with our pellet stove today. It started shutting down by itself all the time, and no clue why. But we figured it out. So just so you guys know, this is not the normal view of the moon. I'm just showing you the moon, you know, this way. Because hey, there's Cypher. Hey, what's up? Nice to see you. Yeah, so if I drop this down, okay, the moon is kind of low in the sky now. Alright, but we'll take a quick picture of it so you can see what it looks like. Yeah, there we go. Okay, you can see that it's really got some issues with the focus, you know. Yeah, well, I turned off the operations cam. I don't need it. Alright, and then you can see that the moon has... It's a little more fuzzy because it's near the horizon right now. And after this goes down, then we move east. And see what's over in the eastern side of the sky. Hey there, LJ's Life, how are you? And you're right, you can see the Earth shine even from here. When you look up in the sky, when it's a crescent, you can easily see the Earth illuminating the unlit side of the moon. Because that's there's nothing else for the Earth light to light up out there, so it streams to the moon as well, and the Earth is pretty bright from the moon. So... Ah, good for you, Daisy and Zoe. Friday night is pizza night, isn't it? It really is. Okay, so this is the view that I was showing you earlier, which I think is a beautiful view, but this is now going back to the live view. And then if I go back and increase our exposure settings, okay, now you can see that we can get that unlit side to show up again. And if I just send this up north a little bit, the other thing to notice too is earlier this star here was over here, but wait a minute, why is it over there now? Because the moon visually moves through the sky. You just don't see it because you're not used to watching just the moon. But if you measure the distance between this star and the top of the moon right there, it'll get farther. Every couple of minutes you'll see it's getting farther apart because the moon is heading that way, to the left, you know, toward the east. So that's actually what's going on. And so with that happening, we will definitely find that the the star is going to get left behind. But earlier tonight, these could both be in the same field with no problem, and now we kind of have to play a little bit of a game to get those to stay in. But it's pretty cool. Indeed. Again, we're just watching for any bright spots to appear on the moon. Can you imagine if we saw a big, giant, slam on the moon? We saw one in that lunar eclipse, remember? We actually watched the meteor strike the moon right about here. And it was confirmed later when they looked at the moon. They actually saw that the moon did take a strike right where we saw it. We were one of 5 groups on the planet that actually caught it hitting the moon, which is pretty cool. Yes, sir. Okay, I can move that star out of the view now. Center it up again. There we go. Hey Birak, how are you? Welcome to SkyTour LiveStream. Oh, Jupiter and Saturn have already set, Birak. We just moved to the moon a little while ago. Unfortunately. Gotta show you something cool though, which I think is kind of neat to see, and you can only see it when you do what I'm doing now, and that is to overexpose the daylight side. Do you see this little spot right here? Can you see that? I think you can. Okay, what that is, and we'll zoom in on it now just so you can see. I'll just do it this way. Alright, we're gonna move it up and get it into the view. Okay. Yeah, check that out. Thank you, Farva. Right there. Know what that is? It looks like it's an illuminated area on the other side of the moon that's not lit, right? The unlit side. Well, that's actually a high peak on the moon that's catching the light from this side. But check that out. It's just going through there. So right now, if you're on the moon right here in the dark during the lunar night, you'd see a very brightly lit peak, wall of a crater or some such right there. Be like, wow, that's just so cool. Isn't that amazing? And that's pretty cool. Now, as the night goes on, we will see that change. Actually, we'll be able to watch how more and more of this is getting illuminated as the night goes on. And we could stay there and watch that. It's just really cool. So, we're actually... It's sort of a unique position because the moon has such raised areas, raised surface features, that sometimes you might actually see, and you will see, that there are things that sit above the moon's surface enough so that the light can strike them and show. And that's what we're seeing here. Thank you, Farva. So that's a really cool view. All right. So I found out that I think it's January 5th, the show that I did with A&E is going to be broadcast right after The Curse of Oak Island. And so it's at 10 p.m. on January 5th on History Channel, I believe. And it's called, what is it called? I can tell you. It is called The Proof is Out There. cool. So you can see that light now. Look at that. Now the moon, let's see where the moon is in terms of its altitude above the horizon. We are looking at, the moon is only 15 degrees above the horizon and diving down. So if we were to back out and just look around now in our sky, okay, we have Mars, which is just not very good looking right now because it's so, unfortunately, so much farther away than it used to be. It is anyway. And then we have over here, we have Orion has just risen. We can see it on the other side of the dome here, but if we remove the dome, you can see that it's right there, and it's only about 15 degrees in the sky itself. So we have some time. So we back off. And again, this is the landscape here. So you're looking at the actual landscape where we are. So the moon's about to enter the trees here shortly. That's the silhouette of the house. And the skies are nicely dark here. They're pretty nice. Okay, so yeah, we're 14 degrees with the moon. All right. Oh yeah, gas mask. You remember that? Gas mask says, I remember the moon structure conspiracy photos. Yeah, I did that show too. It was called Aliens in the Moon. As always, I was trying to be the voice of reason amid the chaos that can ensue when people start making some assumptions without testing a hypothesis correctly. There's only one photo I saw from that entire production that I didn't know how to explain, and that was only because I didn't have enough data on the photo. It could have been a photographic artifact, but I don't know. Monique, I am in Connecticut at the moment, but I will be in Arizona in the future because the other observatory is going in there. So we have one here, and the observatory in Arizona is finished, and the building is done. It's a roll-off roof system, which is just a really, really nice system. And I can show you what that looks like, actually. And I will do so. So let's go. And the way we'll do it is we will do it by showing you. I will show you right here. Okay, this is the building that you'll see right now. There it is. Okay, so that's the roll-off roof building that's in Arizona. That is the door. You might say that's a pretty odd-looking door, huh? It's really strange. It's actually a piece of art. Actually, that's SkyTour LiveStream. You see there, and that's the Orion Nebula. But it's a almost an impressionist painting of the Orion Nebula, but it's not a painting at all. And Tara D, who was in the chat, knows the most about this because she is the one that did this. This is actually a door made of many, many bottle caps, crushed flat and laid out in just such a way. Now, these lines, all this stuff, these are the bottle caps. No additional color was put on this door. These are just the bottle caps. And by putting on the bottle caps in just such a way and cutting them to be straight where they had to be straight, she just did an amazing job. It took a long time, and I am very proud that Tara did this. She's an Arizona artist and amazing. And by the way, look at the handle to get in. You know what that is? That's the cap opener that you see on the soda machines. I think that is so cool. That is so cool. Yeah, you know, Monique, that's crazy. Yeah, and I think that you know, we've taught classes 10,000 miles away, you know, from here, because there's nothing with distance when it comes to doing a thing like this. Okay, here's the SkyTour LiveStream Observatory on the site. Okay, this roof rolls right off onto this take-up rails. We used industrial garage door hardware, and there's a garage door opener in there. And when you turn on the garage door opener, it'll come rolling off. It's just crazy. It's beautiful. It works very well. This is 5 acres of leveled land out in the desert of Arizona. The only way to get to it is on dirt roads for about 15 miles. And once you're there, we have power, we have amenities, water, everything. The thing that's interesting is the observatory is entirely green. We're not drawing off of any sources other than the sun for power right now. And Tara did a beautiful job. Yes. These are some close-ups of some of the pieces. This is the interior. Okay, the inside walls painted this beautiful desert tan. Again, thanks to Marianne Robb and Tara D. Tara Deulis, who is in the chat. The two of them went crazy doing this. There's the garage door opener that literally rolls this roof right off. It's not opened all the way. Actually, it goes all the way off. And there's going to be 3 telescopes in here. There'll be one in one corner, one in another corner, and one more toward the center. And those are going to be the telescopes that will be ours, the one that we're viewing with tonight. The P&K Space Imaging Telescope that will be there for looking at the moon and planets. And then our wide field instrument, which is going to be on the 3rd pier. And it's all going to be there. Yeah. It really is beautiful. And we're very happy that it came out just the way it did. Hey, look, it's Marianne painting. She'll probably kill me knowing that I was showing you this. But there you go. And then they sent me some actual photos to give me an idea of what was actually going on with some of the details. Because I wrote software to control the observatory. And that software needs to link up with some of the hardware, so I had to see what the hardware looked like. Wow. Okay, let's go just a little bit. Let's go a little higher here. Okay. Let's take a picture. Let's see if we can. Let's see if 5 seconds at 1600 would be too much. No, look at that. That's pretty cool. And we see another star over here, and that star will notice that the distance between this star and the moon will close as the night goes on. You know, if you block the right side of your screen, you'd be forgiven for thinking that you're looking at a short exposure of the moon. But you see how much detail we can see? That's all illuminated by the Earth, not by the light on this side. There's no atmosphere up there to help diffuse the light. No. This is just Earth shine. The shine from the Earth itself created this. Haha. Gas Mask says, you need a Space Odyssey monolith out there. Yeah. When I saw it, I said, that looks like a Matty Moe piece. And in fact, it was a Matty Moe piece. The first one. Matty Moe is that pop artist that some of you know. But yeah. And naturally, because the moon's so bright, we're getting this brightening here, this bright area here in the photo. But this is the part that is a really pretty part. And it won't be long. This star is going to be here, and then here, and then here. I don't think we're going to get a chance to see it actually set with the, or I don't think we get a chance to see the star be occulted by the moon. But what happens is when there's a star that's close to the moon, when it goes near the edge, what happens is, if we look near the edge, okay, you'll see near the edge here, there's mountains here. Lots of mountains. I see we have another star here. Okay, so that star is getting close. So you see where it is? Right there. I wonder, now again, the moon is kind of low in the sky, so we might not see it, but we could. But see, what happens is, because there's mountains here, sometimes you'll see the stars look like they'll just blink out. And then sometimes they look like they're going kind of below or into the the moon itself, but it's actually a hollow in a valley, and you're seeing them through a valley. But you can't really end up seeing it like that. But you can see how this is not even. It's going all kind of wonky here, and that's in part because of the photo, but in part because the moon is also has undulating terrain. So that's pretty cool. Wow, I like that. That's pretty cool. So let's go and go back to our live view here for a sec. And I'm going to up this exposure. We'll go to, say, 10 seconds. And I'm going to go to 2500. And this will be pretty bright. Yeah, see, now we can see that star is even closer to the edge of the moon. But this is what we got, see? That's how bright it is. And if we just block this out, you could easily say that that's a photo of the moon that was actually underexposed. But that's shows you just how much light is on the moon from the Earth. It's a lot. It's a lot. Let's go back. All right. Let's go and take a regular photo. Go down to 200 and drop this down. Okay, now you can see the shimmering going on here. That's what happens. The shimmer is on. Yeah. The moon looks pretty, but it's shimmering because of the atmosphere. It gets low. Gas mask says, monolith movement approved. Yeah, Monique asked the question, are we going to look at the planets Jupiter and Saturn again on December 21st when they're closest? If it's clear, we're going to. If it's not, we won't be able to. But if it's just sort of partly cloudy, we're going to give it a shot, because then they'll be the closest. And you remember, we have photos to prove it now. You actually remember what they actually look like together. This is what they look like earlier. Okay, this is Jupiter with its moons, and Saturn. And Saturn's moon Titan is probably right. It could be there. That might be Titan, just not quite exposed enough. Not that. That's too far away. But anyway, so that's that. But we'll watch for any other. Opportunities to look at that, because we love looking at those possible conjunctions like that. They're really cool. And back to our meteor view. Now, see, we have the ultimate record. We can actually just look and see if we can see a meteor strike the moon. You can see it. You'll see it hit. It's just the way that works. Gasmask asks if we know why China keeps sampling moon rocks. No, no. The Chang'e lander. It was the first time in decades that lunar samples come back to the Earth from the moon, and they successfully landed back in China. They successfully landed that. So there's no reason why they shouldn't be going back to the moon. Maybe they want to see what the far side, how it's constructed. Because if you keep in mind, okay, when you look at the moon, right, the moon is an interesting place, of course. But the thing about the moon that's really fascinating to a lot of people is the fact that it doesn't, the moon doesn't have the same makeup on the front side versus the back side. And how can we say a front side versus a back side? Well, we can say that because the moon has a front side that is facing us all the time. It's locked to us. That's called tidal lock. So this face we see here, this is the face of the moon we see. This will become the full moon. Okay? It's just a partially lit ball right now that we're seeing, because it's actually kind of ahead of us and off to closer to the sun side, to the daylight side. So just at sunset we start to see the crescent moon, and then when it's first quarter, it's a fourth of the way around its orbit, and so it looks like a half moon. So that curved white area that you see will become straight up and down. And then later on, as the moon continues around the Earth, then that straight up and down line for the first quarter, when it's at 3/4 of the way around, 3/4 of the way toward full, then it'll be what we call gibbous, and that curve will be going the other way. It'll be bowing out to the left. And then finally, when it goes to full, this entire face is illuminated. All right? And so here we see just what we call waxing or getting brighter crescent. All right? Now what's neat is we've talked about lunar bases. I actually did I went and did a appearance on I think it was Gaia TV just the other day, and talked about the possibility of lunar landings and what they'll have to contend with. How easy versus Mars is it to go? And the answer is it's a lot harder, because the lunar night lasts for a month. It lasts a half a month, right, for you. So basically, if you're over here, then you're going to be in darkness. And if you think you're going to use solar panels to get power for your lunar base, well, you're wrong. Well, how long is it going to take for this to get lit up? I mean, the moon's cycle, all right? It takes half a month for the moon to go through a cycle, right, where the moon goes from waxing crescent to full, and then it takes the rest of that month for it to go the other way. So it's like a 28-day cycle or so. But what are you going to do? Where are you going to get power when you're in the dark? See, now you're talking about nuclear-type generators or something. And what if they go bad? You're not going to get any help up there. In the daytime, no problem. Set up solar panels. They'll be really efficient. However, what do you do at night? So it's a big deal. And in the daytime, the solar temperatures are going to be hundreds of degrees in the sun. And in the shade, right on the opposite side of that object that's being heated so hot on one side, it's going to be hundreds of degrees below zero. So the temperature of the object. So really what we're talking about is lots to deal with. And then when you're in the lunar night, well, what if you have these inflatable domes? How are they going to react to being 200 degrees plus below zero for 20 days, 15 days? Okay, that's going to be a tough call. Lots of things to worry about. And what about people? Where are they going to get their water? Well, luckily we know that the lunar surface is full of water. Not liquid water, but water bound up in the crust. It can be pulled out of the crust chemically. We had down here at the South Pole of the moon, we had put this special lunar, well, it was like a collision with a rocket body, basically. It was called L-Cross, and it landed in a crater called Cabeus crater in the bottom of the moon here. And Cabeus was a crater that was used to actually test the likelihood that there'd be water down there. And as it turns out, there is water in the shadows of the craters here, where there's craters here that are permanently shadowed, and the ones that are in permanent shadow have ice in them, and that ice is what they were talking about. Okay, and so we saw ice get blown up into the lunar surroundings when the collision occurred, but it meant that if we had to make a base, we'd have to kind of stick down there to the South Pole, where these craters were always near the ice, so we'd have water available, right? Well, as it turns out, further studies showed us that the moon has water everywhere on its surface. Not in the same amounts, but it has water bound up in its lunar soils in a lot of places that make it so that we no longer have to stay at the South Pole. Okay, so now the benefit of being on the poles is that you can use solar power for longer than you could if you were, say, in an equatorial region of the moon. Because the solar power up here, you're going to have areas on the moon that are almost always in sunlight. And that's very advantageous, right, if you're going to get power using the sun. So it's kind of cool to think about that way. And so the other thing is that, if humans are going to live on the moon for any period of time, well, then they also are going to need to have light. They're going to need to have vitamin D. They're going to need to have a regular dose of light. So that's going to tax the power systems even more, because we're going to have to use these artificial sun lights basically in order to give them a good dose of the vitamin D that their skin needs. So that's just, that little thing is a huge problem. We don't have darkness on the Earth for 10 days, 15 days, but on the moon we do, so, and as you can see now, there is no dark side of the moon, right? That's only a Pink Floyd album, right? There is no dark side of the moon, really. As a matter of fact, it's all dark. Well, it's not really the case on the moon. It's a ball that's being lit up every month on all sides. So somewhere in the sky, it's always, well, first of all, it's always half lit up, isn't it? From wherever it is in the sky, it's always lit up. Half of it is always lit up. It's just, from our perspective on Earth, it looks like it's different based on how it's orbiting the Earth. So that's kind of cool. Now, that said, when you talk about, say, going to Mars, Mars is more distant. Mars has an atmosphere. Landing on the moon is still hard, but it's only 1/6 the gravity of the Earth. Mars is a little bit more. So that means that we're going to end up having a much more difficult landing on Mars, especially because of the atmosphere. We literally have to do something called aerobraking. We literally use the atmosphere to slow the spacecraft down, because it goes pummeling through the atmosphere, and then a chute is deployed, and it slows down a spacecraft as it enters the Martian atmosphere. We're going to need that too, and it'll have to be a very clever way to land. But that brings up the other problem for a moon colony. You're only 1/6 of what you weigh on the moon. Now, a lot of people will say, hey, that's a great way to lose weight. Yeah, well, it's going to do other things too. That redistribution of your mass long term is going to affect how your heart pumps blood. You're going to be a little more bloated, right? Astronauts on the space station, they find that their face gets puffy. Some get headaches that don't go away. And it's because of the fact that the blood is now pumping everywhere evenly. On the Earth, you see, it's fighting gravity. So it's evolved to pump harder uphill, right? So we can do that when we go to sleep at night. Sometimes you wake up feeling rested. We feel rested. And sometimes you wake up with a headache too. Well, the blood flows differently when you're lying down versus when you're standing up. But on the moon, okay, you're going to be 1/6 of the mass. 1/6 of the weight on the moon. Your mass never changes. It's the weight that changes. And because the mass multiplied times the acceleration due to gravity. Okay, on Earth it's 32 feet per second. Okay, so on the moon, it's 1/6 of that. Okay, so you basically are gonna find that your blood is gonna flow differently on the moon. And if you're up there permanently, well, you're gonna skip along, and you'll be able to certainly do some of those high leaps and bounds. You might be able to skip on the moon and go 9-10 feet between skips on the moon if you really get going, and that's pretty cool. The only trouble is, sorry, Isabella, she says, I don't want to live on the moon anymore. The only problem with that is that on the moon, the other thing that we have going against us is that the soil is extremely harsh. Now, you might just say, just reach down and cup it up. And if you did this, if you cupped some moon dust in your hand and then just did this and shook it off, you'd look down at your hands and you go, I am bleeding. Because what you really are picking up are little tiny pieces of glass. Because mixed in with some of the soil, which is just dirt and rock, you also have these microscopic and not so microscopic pieces of lunar glass that formed from the impacts of the meteors when they struck so many billions of meteors struck. And they actually ended up, leaving this molten glass behind, because when a molten rock is blown apart and little molten pieces fly off, okay, when they come to rest, as they cool, well, they're going to cool, and as they cool, they're going to turn possibly into these little pieces of glass, and then more hit, and they pulverize the glass into further small bits of glass. So the lunar regolith, as we call it, the soil, is really, really abrasive. And if you took a handful of it and rubbed it on your windshield, you'd hear it like rubbing glass on a windshield, going, and it'd be all scratched and ruined. So that's a problem. We'd have to make sure that our vehicles, our lungs, any tools we use on the moon, say we have to drill into rock. If we use a drill on the moon, we drill into a rock on the moon, you know what's going to happen? The drill is going to be going up against glass, lunar type glass, a rock with glass in it. And it's going to wear out the bits very, very quickly. Our astronauts that were on the moon were only there for a couple days. They weren't there for very long. So imagine months, okay? Any kind of power generation equipment, like solar panels, let's say we use solar panels for part of the time. Well, at any one time, because the way the moon is, it's so low gravity, dust is going to go into the air, and from an impact far away, there'll be a pall of dust that goes up into not the air, there's no air in the moon, but we call it the exosphere because there's no atmosphere. So the exosphere of the moon will have this pall of dust that maybe settles down on equipment over time. Or if you drive something, like you drive a lunar cart by a solar panel, that rooster tail is going to go up 15 feet in the air from that panel. The heavy pieces will come down, but the light pieces are going to keep drifting. And where they're going to end up? They're going to go in whatever direction they were going in when they left that moon, and that could be toward the solar panels. So that means that over time you're going to have to then move and dust off these panels. But wait, remember how abrasive this stuff is? When you do that, now you got a problem. You can't even use air to do it, because if you had an air blower, which is not a bad idea, and just blow off the panels, you're not rubbing the panels, but you're pushing that abrasive glass on the panels, and you're going to get streaks of scratches. Over time, that's going to reduce the efficiency of the panels, and they'll have to be replaced. All these little things, you see, that have to be thought of, And Gas Mask is saying, ever see the movie The Titan? Yes, I did. The Titan was about a man who was being bred for living on Saturn's moon Titan, I believe. If that's the movie you're talking about, Gas Mask. And they were trying to make a new home for humanity. And so he was sort of like the first person to go up there and try this. And you have to see the movie if you haven't. I don't want to spoil it. But yes, it's a really, really good movie. Yeah. So, you see, we have problems going to the moon. You know, the moon is a great place to visit, but man alive, you don't want to live there. And because of the nature of the ground and the sediments, the soils there, you have to be really careful how you build, what you build with, how much of that soil gets into your daily process. If you go outside and you use the gloves, and you say you have these moon gloves, and you go out there and okay, the gloves are fine. Over time, though, your outfit, your lunar suit, is going to be cut by this glass. I think it was Harrison Schmidt, and someone in the chat can correct me if I'm wrong. Harrison Schmidt said that, I think it was that well, he didn't say it. I mean, he couldn't go on his last moonwalk if it was him, because the ankle area around his moon suit had been worn through to the insulation. The very rough outer canvas of that boot was literally eaten away by the constant sloughing of his feet through the moon dust as he's doing it, like slosh, 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 okay, kicking it up. It was cutting away at his boots over time, and in just a few hours, he did enough damage to that moon suit so he couldn't take his last moonwalk. Now, what a way to... can you imagine that? I don't know, I might have done it anyway, wouldn't you? You know? I think we'd want to do that. I'd try that. I would. Yeah. But yes, there's a lot of considerations. We love the moon. We want to go there, but we have to be careful. We have to be careful how we approach it. I'm going to do 5 seconds here at 3,200. Maybe I'll do 6,400. Let's go see where that star is now, shall we? Ooh. It'll be closer. Oh, look at that. Yep. Now the star is even closer. Look at that. See that? It was out here before. Now it's closer to the moon. Yeah. The dome is getting in the way, which is why you see a red glow. And that may not be because... Let me just see here. That may be because the telescope is looking now down below the lower lip of the dome, and then I can't do anything about that. But and just by the way, just so you know, you hear me clear my throat a lot. Believe it or not, one of my vocal cords is paralyzed and it doesn't work, and that happened 5.5 years ago, and because of that, I'll clear my throat more. I'm contemplating having some surgery though to fix that. They can't fix the fact that it's not working. They can only fix the fact that it's causing discomfort all the time. Okay, so this is neat. Yeah, see, so that's neat. Now I can also go into a video mode, and we can actually go watch. So this is live video on this side. You can actually see the star right here. At the end of the point is the star. See if we can bring that in more. Oh yeah, now you can see it. There's that star right there. And when it starts going behind the trees, you'll see branches sticking up in here. You know? Yeah, it's almost like a impressionist painting, you know? Moon was a good movie as well. gas mask mentioned that one as well. So we'll just drop out of that video. Very nice. Man, it's looking pretty. Very, very pretty. Very pretty indeed. Okay. Now, all the problems we have living on the moon or moving to the moon, you have to multiply them by a factor of maybe 4 to 6 for going to Mars. The biggest factor is getting there. The next biggest factor is landing there. At least on the moon, we can slow down and then just not have to worry about anything but our forward velocity and our descent velocity. On Mars, we have to worry about about that too, but we also have to worry about the density of the atmosphere and what that does to the stability of our spaceship coming through the atmosphere. Because on the moon, if you come down like this, you'll stay like this all the way to the moon's surface until you turn this way and land. On Mars, if you go like this, it might get torqued one way or the other because of the atmosphere. All right, so we'd have to worry about that. You know. Yeah, and Tara likes this texture along the Terminator. It really is pretty. Let me see if I can make that look just a little better without completely destroying the nature of the view. Something along like this maybe, huh? Now let's just drop that back down in a little bit and take a picture of that, shall we? Yeah, look at that. That's cool. Yeah, very pretty. So we've gone from this, where we've seen, here's a star out there. Okay, and we took some pictures earlier as well. Let's see if we can see the star here. The star is right there in this shot. And then here, the star is closer. Do you see that? It was here on the last shot. Now it's here. So we might just get a chance here to see this. You know? It's kind of fun because you can watch a star wink away. And we'll go to live video when that happens if we can. Just to see if we can get to that. I'd like to show you that. I think you'd like that. So once again, let's go up. And raise the ISO. Yes, it's actually, as the moon gets lower in the sky, it's getting tougher. And let's see where it is. Okay, it's under 10 degrees. The moon is now at an altitude of only 9 degrees above the horizon. And if you notice, according to our map, okay, the moon is going to start going behind some of the trees that are here on our southwestern horizon. Anahata 77 is here. Hello, Bonnie. And you'll see the moon dancing. This is the live view. You'll see it dancing a bit. And let's go up to let's go 32,000 and go live for a moment. Trying to find our little star. Let me just take a photograph and see if I can see it. 8 seconds at 32,000 is going to be a blowout. There's going to be a lot of red because I have the observatory is interfering. Yeah. Okay, we have that star. But then there was one down here that was closer that I wanted to use. Too bright. Let's go down to this. Okay. We'll try that. I'm looking for our star that I want to have to check out here. This is the other one up here. I think that moon's gonna set before that one can be captured going behind the moon. Darn it. I need to move the dome a little. Can you guys hang with me as I go move the dome so we can get back into darkness? I shall be right back. I'll just leave you with the live view for now. Okay, and it is overexposed on purpose. Again, like I said, just to be able to show you. I mean, but we can actually bring it down and have a regular photo if we want of the moon. But look at how it's dancing. Isn't that crazy? All right, I'll leave it right there and I'll be right back. I'm going to move the dome. Okay, dome has been moved. Now, let's go and do a couple things. Okay. I want to bring us up. There we go, and now bring us down and head east. Alright, let's go. Okay. Now we'll take a photo right here. 8 seconds at 640 ISO. I want to see if we can see where our stars are on this side. Capture. See that one? It's closer still. Hold on, I'll show you that better. We had a faint one that's got lost in the glare now, darn it. I wanted to show you that one more than the other. But there's one there. And so I guess we'll have to just... Well, that'll be down there pretty soon. But the moon is low. I was just looking at it in the sky. But that's the star, and we want to watch it go behind. But while we're here, remember that bright spot at the bottom? Well, you can see that now the bright spot is still here, but we're getting a piece of another rim lit up down here as well. I think that's pretty cool. And the blur is not because the telescope's not focused, it's because the moon is dancing around in the sky, as you can see. Let me just show you that a little better. Okay. And if we zoom in, that's the limb of the moon there that you're seeing, but let's go and bring it in. Bring it up. Okay, just a sec. Okay. Alright, and now let's do this. Alrighty. Okay, now you can see just how the atmosphere is doing this nasty bit right over here. You can see that. So as still as you might think the night is, you can see that it's really, really not that still in the end. You know. Hi, Katie Q. Very nice to see you here. Okay, so clearly we have some blur there because of the moon. Okay. Now we'll head over here. I'm going to take the bright side of the moon and move it a little off so we can see this better. Alright, now let's do another. Let's do 2500 for 8 seconds. And we're going to catch the limb of the moon. And look for, see how close our star is now. Wow, look at that. It's getting close. So that's how far the moon's moving. So you can actually see it. There it is. Okay, let me do this better for you. So there you go. See how far away it is? Okay. Then we do another shot. Okay. And now look how much closer it is. It's going to be going behind the moon momentarily. So let's check out a video mode here. Let's crank up the ISO and do a magnified view. Okay, now let's bring it over. Bear with me here. I'm almost there. Okay, and now let's bring this down and get our moon here. Oh, hold on. Oh man, it's going behind really fast. Oh, it's just there. You can barely see it. Oh man, it's right there. Let me take a quick picture. 8 seconds at 6400. See where it is. Yeah, it went behind already. We just missed it, or we caught it, but it was lost in the glare a little bit. But you're getting the idea. You can see that the moon actually is moving through the image, you know, as the night goes on. It's moving across the sky. And that's the coolest thing. All right, so that's enough looking at the unlit side. So let's just take a photo of this right here, as low as we can. Okay, let's go to say 400, but let's do 25 seconds. Now it'll be blurry a little bit, but I want to get a finer view to show you. Hey there, Donald. Zorthan Tech, how you doing? Oh, I'm glad you listened. That's fantastic. See, I told you it'd be a little bit blurry, but that's because the moon's dancing around. So I'm showing you how that works, you know. Very, very interesting. When planets or anything is low to the horizon, you don't get really good clear views because you're looking at so much light that's being danced around by the atmosphere. So when we look here, okay, we see, you know, you can see the moon dancing. You can see the image dancing around. It's gone dancing, man. It's all right. I'm just happy to be here. Looks nice. So the moon is low enough now in the sky. How low, you may ask? Well, now it's actually down below right here. It's actually at an altitude right now of only 7 degrees above the horizon. That's like 2 fingers outstretched, stretched out arm's length, 2 fingers. Okay, and it should be. It'll be getting into the trees soon. Yeah, Donald says, oh, you started early tonight. I did, only because of the fact that Jupiter and Saturn were in the same view. Actually, Jupiter and Saturn were about this far away. Here would be Saturn, and then Jupiter was here. It's about the width of the full moon. When I took the photos of it, I'll show you actually what it looked like, Donald, because you might have missed it. Okay, this is what the picture looked like that we took. Right, so you can compare and see how far away Jupiter and Saturn are from each other. This is not this is the actual size in the sky and to the telescope, and then compare that to the size of the moon, and I'll take the picture of the disk of the moon like we're just showing with the extra light watch. See that? So it would be Saturn here, Jupiter here. It's the moon's diameter is bigger than the separation between the 2 planets right now. So we actually see that really, really impressive display. And I said before that, and I'll say it one more time for those that might have not been here. The moon, on December 21st, actually, Jupiter and Saturn are going to be the closest they've been in hundreds of years. In fact, the last time they were this close was during the life of Galilei. And Galileo, of course, was a famous astronomer and, hated by the church because of his heresy, you see. But he was right the whole time. But the last time the planets were this close was in the time of Galileo. And that close approach will be on December 21st. Just happens to be the winter solstice, but that's just the day it turned out to be. Well, it also is my son's birthday. one of my sons, my oldest. And he was born on December 21st, and it turns out his middle name is Galileo. So it's kind of an interesting convergence, you know. I don't really think there's meaning to it. I just think it's kind of cool. So here we got the moon, and I think that we're going to be getting into some trees. I see a little shadow down here. Looks like we're getting some trees are going to be coming in here shortly. So the views are not going to get any better. They're only going to get worse. But let's just try, just for fun, let me just drop this way down to a more respectable amount just to get an image for comparison. Okay, you'll notice how the moon's actually a little bit redder right now. It might be able to affect that. Maybe this way. Just a sec, I'm working on a couple ideas here. Okay. So that's sort of what it looks like right now in the sky. It literally does so. Yeah, just like, kind of like that. You know? Yep, that's about right. And I'm doing a color correction for the filter we're using as well, so that's what's going on there. All right. Well, now I think what we might want to do, because the moon is literally, now its altitude is 6 degrees 42 minutes above the horizon. I think we're Jupiter and Saturn have set, and I think what we want to do now is head up and look at the Pleiades, maybe. Would you like to go see the Seven Sisters? Yeah, I think they'll be pretty. Does that sound good to you guys? So what I'm going to do, thank you, Farva.
Structure in the moon you will show me.
Yes.
Show me you will.
That's cool. Who watches The Mandalorian, by the way, with Baby Yoda? In this last episode, he takes off his mask, and you see his face.
Yes.
All right, I'll be right back. I'm going to go move the dome, guys, and I'll just leave you with the setting moon. Just so you can actually enjoy that for a while. I shall be right back. I'll move the dome. But when I do, the moon's going to go away, okay? Because I'm heading over to the Pleiades now. So I'll be right back. Guess who? All right. I told you the moon was going to go away. I apologize for that. Hey, Amanda Smith, how are you? Oh, yeah, it's Grogel, wasn't it? That was his name. Grogel. You say Grogel, he goes, eh. Oh, man, yeah. I'm wearing my black hat. This was part of my outfit for the show I just filmed. I was one of the cast members for this new investigative show. We did 13 days of filming in New York State. It was cold. All right. Now, let's go to the Pleiades. Off we go, and we will check, and I'll take care of. Okay, telescope's on its way. All right. And I got to get rid of this. And we'll bring the speeds up. And we should see the star come in. Okay. I look cold, Katie. Daryl was here earlier. Donald asked, no, Daryl, he was here earlier. And there we go. Ba-boom. And now we've warmed up to the Pleiades here. This lower star here is Alcyone. That's Alcyone. And we'll move it up into the field a little better. And there's the star we're after right there. That's Merope. We're going to head to the west a little bit here. When you look up in the sky and you actually see these 4 stars plus another one out there. You can see about 7, but there's actually many stars associated with the Pleiades, and you don't really see what they are right away. You can't really tell. Now we're using a filter that'll allow us to see some of the details of what's going on around these stars, and I think that's pretty cool to look at. Don't worry, Donald. If Donald says, oh, that's what happens when you're late to the party. But it doesn't matter, Donald, because you're right. It's a stream. We can just go back and watch again, And I appreciate that you guys like to do that. If it wasn't for you guys, I wouldn't be doing this. You guys have such a good time here and you enjoy it, so I like it. And anytime that you don't enjoy it, you just tell me and we'll be done. I'll quit. And Farva at it again. Thank you so much. Okay, now let's bring this up again. Okay, this is Merope here. And the Pleiades in general are B-type stars. That means that they're not quite the hottest. O stars are the hottest. B stars are the next in line. Okay? And the B stars can still go and will go supernova. When they have their ignominious end, they run out of their fuel, they will go supernova eventually. And these stars were all born in the same place. And earlier we talked about the sun, trying to find out where the sun was born. We have to look for stars that have the same composition as the sun. Okay? And we found a stellar sibling, one of our sun's siblings. But here, we see the siblings of all these stars. They were all born in the same place. Hey, Donald, thank you. Thank you so much. And so when they're born in the same place, like these stars were, then they're going to all be approximately the same type. And these stars are all B-type stars, the main stars. And they're also orbiting the galaxy as a cluster and they're gravitationally interacting with each other, and their shape relative to what we see is going to change over time, all right, as that happens. But as they orbit the galaxy, they're moving into different dust clouds, passing through dust clouds, and so forth, and then keep on going. And the Pleiades have moved into a dust cloud. These stars that form the Pleiades have moved into this dusty cloud. And so around these stars, although you can't see it readily, we actually have a very, very bright blue dust nebulae that are around these stars. And I'm going up to 25,600 ISO up there, and the sensitivity. And we're going to go to, like, let's say, start at 25 seconds. And let's look around Merope here, and we're going to see a dust cloud. All right. So let's go. Here we go. And as you'll notice that it's sort of like it's like brushed. It looks like a brushed material, like right here. All right. So it's going to be like right here, kind of coming down like this. All right. And that'll look really pretty. You'll see it right there. Okay. So it won't be as obvious, and because the moon is still up, it's going to have a little extra trouble, but we're going to see. Oh, that's not bad. It looks like it worked okay. We can kind of see it. Okay. Okay, as you can see, you can see this brushed look right here. You can also see there's other blue haze in here. There's the modeling of the cloud. You can see it very clearly there. This is really interesting stuff. Okay. One thing I'm going to do is I'm going to change some of my settings here. Okay, I'm going to go back to an earlier set of settings I had here. Let's do this. Let's do this again. Okay, so 25 seconds again. We'll take another picture. I'm changing the color response in the camera to try and make these nebulae a little more obvious. So we'll see how we do. See how it works. All right. So let's check it out. Okay, so this is another view. And again, only 25 seconds. You can still see the modeling of the color. You can see this hazy stuff right here. You can see that very clearly. That's only with 25 seconds. Now, here's what we're going to do. We're going to take this up to this impossibly crazy 64,000, and we're going to go up to 30 seconds now. All right? It's going to be bright, but we're going to see a difference in the nebula. And one of the things I've done is I figured out how to process photos that are taken with a very, very high ISO. Now, why does that even matter? What does that mean? The ISO is the sensitivity of the sensor, okay? And the more sensitive you make it, like this, 64,000 versus like 50, okay? 64,000 is pretty high. So the more sensitive you make it, the more digital noise is going to show up, okay? So here we see a very bright image, all right? And if we were to zoom in on this, all right, you'll see all this modeled noise. But I figured out how to get rid of all that, all right? And now if I move this around, see that? By moving this around, you can actually kind of see the dust cloud right here that it's in. See it? You might lose it if I stop and you just stare, but by moving it, you actually see that dust cloud very, very nicely. Okay? And that was what we're after. And then you move away, and the farther away you get, the more actually it looks like you can see it. Okay? Now I'm going to do another thing. I'm going to take us... I know I'm fast, but you know what? I'm doing it this way because all these photos I'll put up, as I always do, on our SkyTour LiveStream Facebook page, Facebook group, and you'll be able to capture them and look at them there as well. All right, now we're going to go over to Maya. This is another little star that's really pretty. And we're going to do 30 seconds at 64,000 here as well. All right. And now watch what we see. There's going to be a different dust cloud that Maya is shrouded in. Again, the stars are passing through these dust clouds. And they're a few light years from the dust clouds, but the dust clouds are illuminated by these stars' light. And that's why we're seeing them. They're called reflection nebulae. And reflection nebulae are nebulae that are taking the light that comes from the stars, that is the dust clouds that are doing this so-called reflection. And what they're doing is they are actually scattering the blue light in the same way that we see a blue sky. They do the same thing. So here is Maya. Look at this curly Q shape right here. You see that? That is the Maya Nebula, and you can see it when we move this back and forth. It becomes very, very obvious. Okay? Isn't that beautiful? And so now when the bright star like this, which has a very, very bright blue light, when it sends out its light, these dust grains, the dust that's in here, the dust grains, okay, the tiniest part of the dust, they absorb all the colors of the light. They absorb the light that comes from the stars. Most of that light they let through and just passes through unimpeded without doing anything to it. But the blue light, because it's so high frequency, that blue light is effectively, think of it as being bounced around inside the atoms, okay, of the dust grains, and then when it gets bounced out, it goes any direction it wants to. That's called scattering. And that scattering that we're seeing here is what we call this reflection nebulae. It's reflected light and scattered light. And it's the high frequency light that's scattered in nearly all these nebulae that we see. That's why when we look at the Orion Nebula later, yes we will, you will see things like a blue streak here and there, and those blue colors are representative of scattered starlight. And so that's what's happening here with the Pleiades. As these stars are passing through this region of space that's very dusty, their starlight is being scattered by the dust, and that's why it appears that there's a dust cloud shrouding these stars, but they weren't formed in this dust cloud. This is just dust. And stars don't form from just dust. They have to form from lots and lots of gas, hydrogen primarily. So that's really interesting. Now you might say, well, why hydrogen? Well, you know what's interesting about hydrogen is that hydrogen is the most prevalent element in the entire universe. And the answer as to why that's true is because it's simple. It is one nuclear particle in the center with one electron. So it's a proton and a single electron. So it's just a proton and an electron, the simplest atom you can have. What's the next simplest one after hydrogen? You probably guessed. Helium. 2 protons, 2 electrons. Right? And then lithium, beryllium, carbon, nitrogen, oxygen, phosphorus, all the way through. And one of these days I'll be brave enough to actually sing you the periodic table, because I can do it. I can sing the entire periodic table. Yeah, I don't have a life. So, I mean, that way you guys will be able to know what the elements are, and it actually is pretty cool. So, there is that beautiful Maya Nebula, and it's beautiful. And incidentally, you'll notice all the other stars. Okay, see all these other stars in here? These are relatively bright ones? Yeah, those are all part of the Pleiades. Those are all stars that are part of the Pleiades cluster. But, you know, only the brightest get to get listed in the catalog. So all these little stars are going, why do they always get the limelight? You know, well, it's because they're the brightest ones, that's why. But look at that, that's beautiful. Just beautiful. You know? So you move it and you can see it much better when you move it. You know, moving it helps you actually differentiate. And it's this curved thing right here. You know? Very cool. Very cool indeed. You know? So, let's go see if we can go back down and get us at this high exposure. Let's see if we can grab the Merope Nebula with a little bit more panache. That is to say, a little bit more crazy stuff here. Okay, Monique Coleman, thank you for coming out and hanging with us. It was a pleasure to have you with us, and we will see you again soon. Talk to you soon. Okay, and now we'll take a picture of Merope again. And while we're waiting, we can head back over and check out our latest image here of the Pleiades. And the Merope Nebula will come in right after it. There's a 30-second shot at 64,000 ISO. So this will look a little different than what we saw before. And then we'll take it with a different filter. And that is going to look even more interesting. Oh, look at it. So now you can actually see some of the other nebula. This is actually here, that's a lens aberration, a lens flare. But you can see some of this other stuff here. This is more dusted here. Okay, and there's more dust in here. It's really pretty. I would actually like to take a picture here now with what we call the narrow band filter. This is a narrow band filter that we're using now, but we have, if we look at our image here, okay, for those, again, I see some new faces out here, but I just want to quickly go over this with you guys so you can see. Okay, this is our telescope control system over here, and then down below me here, okay, this is the telescope computer that I can get into and make changes and focus the telescope. But then right here, okay, you see where it says right there, it says narrowband 2. Okay, this is a filter wheel that I have here, and so what I'm going to do is I'm going to hit that left arrow, okay, that's right over here. And the left arrow that I'm going to hit is going to, you know, it's right here. And now I'm going to take us and go to narrowband 1. And you'll notice that fewer stars are even showing up now. So you'll say, well, nothing's going to show up. But here's how it works. Narrowband filters don't just look at the whole broad spectrum of light that's coming from the star. Okay, they take little cuts through the spectrum, little tiny swaths through. Okay? The narrowband 2 filter, the one that took the previous shots we've been looking at, is fairly wide. It takes a fairly wide swath here, fairly wide swath here, a wide swath there. So you get a lot of additional background light, and the nebulae sometimes get lost amid that. Now, with narrowband 1, these slots are very, very tiny. So we got 4 of those. 1, 2, 3, 4 at all the most important locations in the spectrum. So now, let's kick this up to 80,000 for 30 seconds and do a shot now of the same thing that we did before. Okay, this is the Merope Nebula and its environment. Okay, and you can see the additional nebulae here. They're sort of faint, but they're there. You can see the nebula here, okay, around Merope. And then we have other clouds that you can see in here. In fact, if you move this around, you can clearly see that there's stuff here and here, and there's stuff right there, you know. But now, when we look at the narrowband filter, now look at this. Here's the narrowband view. It cuts out all the crap, okay, and allows us to see all the real stuff, okay. And let me just do some instant processing here. Wham. Okay, there's a little magic processing there. And now this shows us, you can see now the linear streaks I was telling you about right here, very obviously. And man, this is a live shot out of the telescope, so we're not talking about a processed photo. We're talking about a live shot taken right here. Okay? Yeah. So now if we go over and take us back up again to Maya, the Maya Nebula, and the star Maya. Okay, there's Maya right up there, right here. And now we'll do 30 seconds here. Now every time I move the telescope that's guiding, there's a guide telescope on top of the main telescope, and I have to wait 11 seconds for it to acquire a guide star. So by now it has. So we're going to do our 30-second shot, and then zip on over to here again. And now we're going to be over at the Maya location. And the Maya location will show up here in just a minute. So there's this. This is our view, and then you'll see that these will drop down, and Maya will be up here with its nebula. Any second now. Yeah, now look at that. You can clearly see the nebula around here now. And that's what the narrowband filters do. They allow in the light that matters most. Okay? And they don't care about the light that doesn't matter. And so, whereas you think it may not show you as much, in fact, it shows you way more. So there you go. That's how the narrowband filter systems work. See? So, in that case, let's now go back over here and let's bring up our system, our control system. And if you'll notice, I'm going to go up to those filters now, and I'm going to change the filter back to narrowband 2. You'll see more stars show up because the filter is not as limiting. Remember, it's the wider path, wider slots through the spectrum, right? And then we're going to go to a different location. Now, where you might say, I got an idea. How about we try going down to the Orion Nebula? Would that work for you guys? I would hope so. So we're going to go down and head to the Orion Nebula. And to do that, we got to go right here. Yeah, the Orion Nebula is beautiful. So now, when I tell it to go, you'll see the stars of the Pleiades disappear because the telescope's going to race away. And in order to see that, we have to, I just have to let you watch the telescope cam down here. So watch down here, the telescope cam, you'll watch it move. All right, so I'll bring this up. We're on the Orion Nebula, and away we go. Here we go. So there goes the stars moving, there goes the telescope moving. The telescope's on its way down to the Orion Nebula, but it's going to find a star first. Okay, what is happening here? I don't like that. Oh, I think this is yeah, this is an error. I will fix that. Okay. Let's make sure that it's still coming up. Oh, don't do that to me. Not fun. Okay. See that? How could I not have a camera connected? That is totally bogus. Not fun. We're just going to the Orion Nebula, and just like that, you're gonna play games with me? Ugh. Okay. Tell you what I'm gonna do. I'm gonna go out to the observatory in the cold, and I am going to try and figure this out. Alright? I am not happy about this. So I shall be back. I'll be back in a minute. Well, I'll be back in however long it takes me. One more time. Okay, I'll be right back. Sorry, guys. Live observatory. What can I tell you? I'll be right back. Ha! I win. I win. Okay. Telescope is back. Actually, I learned something about this too, which is kind of interesting. The problem that I had, I could have fixed from in here. It wouldn't have been easy, but I could have done it. Okay, so we have a very interesting image here. We have the Orion Nebula, okay, is down here. Okay, no, not you. That's the Orion Nebula right there. Okay, and then right up there, we have another nebula that we love. It's near and dear to us. It's called the Running Man Nebula. Let's do 30 seconds at 80,000 on this. And this is with, if we come in here, you'll notice we have narrowband 2. So we have slightly wider passes. All right. So let's do that. Let's just do that shot. And then we'll change it. All right. Let's go see. And now because of what we did, here we go. Yes, I know there's no media files. They'll be here in a minute. It'll be here as soon as we get this in order. Oh, a little bright. Just a little too bright. My mistake. Okay, let's do 25,600. My mistake. I apologize. Yes, the Orion Nebula is almost off the bottom, and it will be, and this is almost off the top. Intentional for now. Carol Carl, that's nice you talking about the Tracy Austin show, but what about the Carol Carl show called Behind the Obsidian Curtain, Friday nights at 7 p.m. on kgraradio.com. Followed on Sunday from 8 to 10 p.m. by SkyTour Radio, with yours truly and Amanda Curran and Daryl Mason. Wow, now that, see, is pretty. Right? That's really pretty. We see this nebula up here, and we see the Orion Nebula down here. By a show of hands, who hasn't seen the Orion Nebula yet? That's a joke. Who actually raised their hand? Don't worry, I saw it. Okay, what we're going to do is I'm going to bring us down, and I'm going to bring the Orion Nebula up now into the view fully. Oh, it's fine, Carol. Actually, Carol Carl, would you like to join me and come on with us right now? I wouldn't have a problem if you'd like to join us right now. You tell me if you would like to, and I'll bring you in. All right, so let's just take a picture now. First of all, while waiting to see what Carol says, I'm going to bring us, I want to get a live, nice close-up view here. Let's see here. Okay, so now what I'm going to do is bring us those stars in a close-up. Mr. DeMille, I'm ready for my close-up. Hey, look at that, see? So now in the center of the Orion Nebula, we have this, right? And let me just grab Carol here. Okay, I'm calling Carol now. Oh. Thank you for answering so quickly.
Well, you're so welcome.
That saves everybody from having to...
Yeah. No eyelashes here. Yeah.
So this is Carol Carl, host of the Behind the Obsidian Curtain on kgraradio.com. And Carol is a good friend. She's also... we work together, not together directly, but yeah, on KGRA as radio hosts, right? And we have a good time there. I was just trying to... I'm going to focus this guy. He's just like...
Oh, you're welcome. I'm hearing a loop back.
Are you?
Let's see. I don't know. I have to turn something off.
Okay. Well, if you're hearing an echo, that could be mean. Okay, we're fuzzed out, and now we're gonna bring it into focus.
We do. Can you hear me?
I can. Yeah, what do you got? You got some kind of echo?
Doggone it. I know. I shut off one computer. Okay. So that thing is turned off.
Okay.
Echo. Yeah. I know. Wait. Now do we only have one stream?
One stream?
Doggone it. Go with the flow. I'm hearing what I said a couple of seconds ago.
Oh. Do you have your YouTube? You on YouTube? You mute the YouTube.
I was watching you on YouTube, yes.
So
what
mute
do I...
that,
okay.
Because that's what you're hearing.
Where's Amanda when I need her? If I hit live, maybe that will...
No, just go to YouTube and I'll share my screen so you won't have to worry about watching this on YouTube. That's why you're hearing an echo. Wow.
I'm seeing something extraordinary.
Yeah. There we go. So did you find your YouTube?
I think I just exited YouTube. Listen, let me shut it all down. Let me Okay, wait. How about this?
Okay, how about it?
This sounds pretty solid.
Yeah,
yes.
You sound fine.
Okay, cool. You do too, and I don't have that pesky
There you go.
something I said 10 seconds ago. Hello, everybody. This is a great treat.
Yeah.
I want to tell you. Yeah.
So
Wow.
there,
Oh my
there's
God.
the
And
nebula. Isn't
yeah.
that beautiful?
No hands went up when you asked who had not seen it. I didn't see a single hand.
Wow. So as you can see, the Orion Nebula is beautiful, and this is with the somewhat wider narrowband filter. I'll take one now with the very narrowband filter, and then that we have to take this down. Let me just show you what I'm doing. I'm going to take up there. I'm going to take that arrow right there, and I'm going to knock us down from this 2 here down to 1 by hitting the left arrow. So boom. Now you'll see this is moving, and then it goes to 1. All right. Now we will take a 15-second photo at 25,600 ISO. And again, tighter slots, but we're actually using a filter that is literally tuned for these types of nebulae. So we're going to see some really beautiful stuff. And this is, of course, a nebula that's near and dear to Tara's heart, because Tara created the door to our observatory by using one of these very images that we took here in the observatory.
And can I just say it's adorable?
Oh, you can't. You can't
okay,
say
well,
that.
yeah. I'm sorry, you can't edit that out. It's live.
No,
her work is just, and every time I look at it, I see a different thing, and it boggles the mind. Tara, you're just extraordinary.
Yeah, see, we've said that before, Tara.
Yeah, I know. It's redundant. Just have to keep telling her because my gosh, what a lot of work that was.
Yeah.
And now she has to start rebuilding her collection of bottle caps all over.
Well, she used a few thousand, as we've said, right?
Yes.
Yeah, we haven't given an exact number because the person who does give the exact number, or I have to be honest, okay, if they're within 25 of the correct number, then the first person that gets that to me is going to win one of our 3D printed, SLA printed moons. And it's beautiful. It's really stunning. And I even did an SLA base for it, which I'll show you actually.
Oh, cool.
Yeah, I'll show you guys. Why not?
So,
let's see here. We're in this.
Yeah, you can hold the moon in your hand.
Yes, you can. Now, I'll just be right back. Here, I'll show you this. It's just a sec.
Okay.
All right, 1 second.
We'll just talk amongst ourselves here. Isabella says, Tara, Orion Nebula plagiarized your artwork. Yeah, talk about audacity, right? Jeez, who are those guys?
Okay, I'm back, but
All right,
I'm not plugged in yet.
Okay.
I feel like some kind of commando. I'm an astronomy commando here. That's what I am.
It's the hat.
Yeah, it is. I'm an astro.
Yeah.
I'm an astro commando.
Yeah,
Okay.
there we go.
So this is our moon, and it comes on a beautiful base as the moon. Okay.
Strangely. Yes.
And it really is quite accurate.
Is that a moon base? Oh, I couldn't resist that.
It is a moon base.
A moon base.
I drew that up and we 3D printed that, and I did that. So it's actually, you can see the C's of the moon. It's actually quite accurate. I wish I could, I can do this. I can show this more accurately. Look, I want people to see what they can get if they want it. And then I'll get back to astronomy, I promise. Just let me do this little silly thing here. Okay. So, here is what the moon looks like. Okay. It literally has almost every crater on it. You can't. Some of the craters are very, very obvious. And it's a piece of art. It's a hand painted exactly as the moon should look. Okay. So each one is hand painted. See, like this is, you can see, this is Copernicus crater right here. Okay. And then Plato was up here, and you have Merimbrium here. You have all of it right here, and you have the far side of the moon, and you have the near side. And when you look at this, you can actually see something that we learned in the physics of the understanding of how the moon was made, which is that the near side of the moon has all these maria, these dark seas, and the far side is mostly craters. So how is it that the far side of the moon is mostly cratered, but the near side has this on it?
Yeah.
It means that the near side of the moon actually has a thinner crust than the far side. Well, how could that happen? When the moon was young, when the Earth was young, they were both being bombarded by asteroids and meteors. And these meteorites and these impacts actually caused the moon to be put into a molten state a lot, same with the Earth. And as it was starting to cool, more meteors would hit, and what happened is it would throw material up around the moon, like the splash, basically. But the Earth was also going through this, and the Earth had a lot of radiant heat that was radiating away from it. And that radiant heat would push, this is the near side of the moon now, the radiant heat would push those particles that were up in the area around the moon toward the back, where they would come to rest on the back side, gradually thickening the far side of the moon and making its crust thicker long term. And so that's why we see areas where meteorite punctured the thinner front side of the moon, and magma came out, and lava then, magma is deep inside the geology. When it's on the surface, we call it lava. And then the lava spread on the moon. And so when we had that happen on the moon, we ended up with a kind of a football-shaped moon, where it's actually thicker on the backside, and the center of gravity is not in the dead center of the moon. It's actually shifted toward the back a little bit. And because it's shifted toward the back, and it's tidally locked to the Earth, so it goes around, if the Earth is here, it goes around the Earth. It faces all the same direction. Well, that issue is interesting, because you wouldn't think that having more mass away from the planet just wouldn't actually have the moon, just like if it's more massive on this backside, you would think the moon would just go vloop and flip around and be locked this way with more of the mass facing the Earth. And it's not that way. It's actually quite the opposite. So it's a very strange but very acceptable irony that the moon has a thicker the moon has a thick backside.
That's kind of like moony poetic somehow. Well, can I ask you a question that Isabella has posed in chat?
Oh, please do. Sorry, Isabella, I didn't mean to miss it.
No. Well, it's in reference to Tara's incredible door. She wants to know 25% or 25 pieces within the right number. Now Tara says she thinks it's 25 pieces. Tara's
correct. It's within 25. Yes.
All right.
First person to come within 25 gets one of these on a base. I bought the mold making material so that I can make the mold of it. I make these types of things for a living, so I mean, it's it's fine. And the mold that I make is gonna make a beautiful moon like you see here. Each one's gonna be hand painted, a piece of art, and they may sell for they're not gonna be $10 items. These are gonna be more. By far, so these are going to be little pieces of art. So it's up to you guys if you want to buy one when they're available generally, but whoever can guess the right number of bottle caps in the door, you get it. And the thing is, you can count them all. Okay, the photo I provided allows you to see every single cap, and you can count them. Okay, but it's a matter of noticing that some are overlapped, some are cut down. All right, again, you have a slush of 25 that you can get by with if you can do that. But yeah, so I think that's pretty cool.
I think it's extremely cool.
Yeah. I'm okay with it. Yeah. So now what I'm gonna do is I'm gonna take a photo that's a little lower. I'm gonna go down to just 3.2 seconds at 25,600. So. We're going to just do that so you can see something else going on with the Orion Nebula. That's beautiful. Okay, so now when we look at the Orion Nebula here, okay, we're using the narrowband filter now. You'll notice these dots. These dots are noise that are induced by the narrowband filter. I can get rid of them with a quick little processing here. But you'll notice that this nebula has some modeling in the middle here. That modeling that we see in there is the result of these stars are very hot and very young. These stars here in the center are called the trapezium. There's 4 of them, and they look like a trapezoid, and they're so hot that they're causing this entire interior to be illuminated and glow. And the hydrogen gas that's in here, they're making the ultraviolet radiation from these stars are causing it to do that, to glow like that. And there's oxygen in here that glows like this. It's really unbelievable. When we look at the other picture, okay, that's just a little bit more detailed, okay, and let's just process that a little. Okay, you'll see these outer wings here. You can see that these are not the same color. These are actually more of a greenish blue. And that's oxygen in the outer parts of this nebula. Oxygen in here, again, being caused to glow. And this part here that you see, this is a tongue of dark dust that's reaching over in front of the bright nebula behind it. So this is in front of it. Think of this in 3D now. And it's in silhouette against the much brighter nebula behind it. And there's that stuff all in here as well. Okay? Now, if we go back and look at that with the other filter, it's not as readily apparent how that works because we don't really see the real separation between these two parts here where this dark is supposedly in front of this. But when we come and look at it in this other filter, it's a little bit more obvious. We can see that it's definitely a separate piece entirely. So it's really a beautiful nebula. And there's a number of things that are really fun to look at with this in this region, you know. Not just the Orion Nebula. We have things like, I'll show you, things like this one. We're going to go to, this is called the Flame Nebula. It's another nebula that's much like the Orion Nebula. All right, and the Orion Nebula is going to disappear for a second as we go hunting for the this new one. All right, and then we see a target star coming in down here, and it gets centered in the view, and then off it goes. You'll see it disappear, and then we go to this location for this particular nebula. Amanda's here?
No. Terry Groff says that he was just Skyping with Amanda, and she's getting ready to do a video thing for KGRA.
Oh, okay.
And she says hi to everybody.
Yeah, I told her we were streaming and she could join us if she wanted to, but she could not.
Yes, I know. I mean, my God, she is multitasking like a madwoman. I Skype with her on a regular basis, and it was like, okay, yeah, she has her hands. Her capable hands are full.
Is she producing your show for KGRA?
Yes, yeah. Well, we did the first initiatory foray. We did a pre-record for Christmas Day with Britton Buchanan, and it was so great to have Amanda watching my back. You know, yep, she will be my StreamYard producer, and more video to come. Oh my God! But it's great knowing that she's in charge because capability. I just want to say.
Yeah, that's beautiful. Okay, let me...
she's amazing. Okay, and as Genghis says, huzzah to Amanda. Indeed, many huzzahs.
That's right. More huzzahs than anyone has ever had. You know, a multi-huzzah.
That's right. There should be a new word for it, in fact, altogether.
Yeah, she's a multi-huzzah.
There we go.
Yeah.
Sounds like a title of some sort.
Yeah.
I think at one point I remember you calling her Queen Amanda. Yes, and she is.
That was one of my names for her. Yes, it's Queen Amanda.
Exactly. Yeah.
All hail Queen Amanda.
Yes.
The Queen Amanda. You know?
Right. Ancient Egypt or something.
Yes.
Yeah.
Okay, we're gonna go 25 seconds here at 25,600 on this nebula, which you cannot see, but it lives right here. So you shall see it show up in a moment. It's called the Flame Nebula.
Ah, the flame.
Yes, and I'm in this is my Astro Commando look. Well, I'm not much of a commando. I can't see anything. There we go. Okay. Yes, there it is, but it's... it's not quite there yet. I gotta bring it in. Better. Orion is still kind of low. So I'm in a little bit of some of the murky haze. But 25 seconds here. Let's find out if this will work. Then we'll take a shot with the other filter. Marianne still here?
She just came back, apparently. Yes, indeed,
Marianne,
she did.
what are you
And
doing?
I'm also seeing Daryl.
Daryl's back. Yeah, you're right. Hey, Daryl. Daryl said he was going to come back. And I started the stream early because I wanted to look at Jupiter and Saturn together in the sky, and we did. But then they
I got
set.
a chance to see that before I had to leave. Yeah, that was extraordinary.
Yeah, then they set, and then we ended up looking at the moon, and then we watched the dark side of the unlit side of the moon to see if we could see meteor strikes. And we did not see any tonight, but doesn't mean they don't happen, because they do happen quite a lot. And this is the Flame Nebula next to the star Alnitak right there. You can see the flame. It doesn't look too exciting with this filter, right? But then again, we're asking ourselves to cut through a lot of the murk and haze that the constellation still sits in. But what I'll do is I will take us down to the narrowband 1 filter that I just took us to right there. There it goes. And I will bring us now up to, say, 40,000. Let's go to 51,000, 64,000 for 25 seconds.
Meanwhile, I should toss this in. Daryl says, want me back on.
I'm already
Listen, if you
going.
want to bump me and bring in that guy,
I'm not bumping
feel
you.
free.
I
we could both.
don't want to bump you. I want you to hang out.
Okay.
I asked
Alrighty,
you to
cool.
come in
Love
for
it.
a reason, because I wanted to have you with us here.
Bless your
You're
heart.
really good with us, and now I'll bring in Daryl too.
Fantastic. Love
Sure.
that guy.
You guys.
Marianne says she can't stay long. She's got to be up at 4 a.m.
Yeah. Okay. Well, here comes Daryl now.
Oh, terrific.
So Daryl will join us momentarily. Daryl was here earlier, if you guys remember. Daryl Mason. He'll be back on here in a moment. And he's probably thinking, oh no, I forgot my headset. Then he'll forget to unmute. And then we'll not know what to do. Yeah.
We will be patient.
Yeah. I probably caught him off guard. Yeah.
And as Tara says, the more the merrier,
Yeah.
always.
You there, Daryl? He's still not. He's not there yet. Okay. Okay. Well, we'll try him again. Try him again. Poor Daryl. You know.
Beep, beep, beep.
Yeah. So now.
Boy, even with the murk, that is spectacular.
Yeah, it's just too murky. I've seen so much better. We got when Orion comes up higher, it's better, in general. But that's all right. Let me take us back down to narrowband 2. Yeah. Okay. And now let's do 25 seconds at 64,000 with this. Okay. Hey PG, how's it going? Genghis, what's happening? Good to see you. And Ronald's here. Yeah. So you guys, we had fun tonight, I think. It was actually kind of cool to see all those things. Yeah, now we have...
Daryl says, hang on, dang it. So, okay. And Adam Lorber is in the house.
Oh, Adam,
He
right,
and he wants to know when you're going to start selling those moon sculptures.
Yeah, these guys are going to go on sale probably just after Christmas. I was trying to get them for Christmas, but unfortunately I'm not going to be able to get them before Christmas, I don't think. But I will get them out as soon as I can. You know. So yeah, this image you can see it's still pretty bright. There's the extent of it right there, but I don't know why it's actually so blue. Let me check one thing here. Let's just check one thing.
While you're checking, Terry Groff reposted. Amanda is she's StreamYarding, right? She's StreamYarding tonight for Jill Hansen.
Okay.
Yeah.
Very good.
There's a link. If we're done by then, otherwise you guys can't leave. You just
Okay.
Can't leave. Okay.
Can't leave. Huh. Can't leave. Who says we can't leave?
But yeah, right. So Donald Kunzer wants to say, he asks if there's any chance we could check out the Orion area during the next new moon.
Oh yeah, actually, when the moon sets, looking at the moon is just beautiful, and that's just kind of what we did. So right now we're looking at the Flame Nebula over here next to Alnitak, but it's actually kind of in the murk right now a little bit, so hard to see. In the Arizona Observatory, we will be spending time looking mostly toward the south and to the west. Toward the east, there's a faint light dome of distant Phoenix, and that's enough to ruin the view for me. For most people, they'll say, wow, it still looks beautiful, and it does, but it's really beautiful out there. You know, the sky is so beautiful. We have Bortle 3/4 skies, which those are the ratings. To give you an idea, Phoenix, it's a scale of 1 to 9. Actually 1 to 9, and then 0 is the worst. We're in 3/4 skies out there. Now we still need to be near infrastructure, so we need electrical, and we need the water. We need power, of course, I said. But we also, need a way to be able to get the internet fast, and we're using satellite internet to begin with, but we're gonna quickly convert over, believe it or not, to Starlink.
Is that ironic?
Yeah. Daryl's with us.
Daryl's with us. I hear his tea kettle.
That's correct.
Knock. Yeah.
Hey there.
Hang on just a second. Hello.
Hey, make me a cup of Daryl.
That's kind of funny.
Yeah.
That's really funny.
Yeah, Daryl says knock knock, and Tara says who's there. Okay.
Daryl who? Daryl be hell to pay if you don't turn off that tea kettle.
Oh my God. Oh my God, it's the hat. The hat's inspiring you to do that, right?
Yeah, it squeezes my brain.
Yeah. Okay. Okay, well, I guess that's a good thing.
I guess. Yeah, it's kind of weird looking, isn't it?
Okay, hello.
Hiya,
Sorry
Daryl.
about
Hello. Hey there.
That was either really good or really bad timing, one or the other.
I thought it was great. I thought it was great.
Yeah, very cool intro, or I should say a very hot intro. And Adam Lorber wants to know, Daryl, if you're making herbal tea.
Green tea.
Oh, swell. Yum, my fave.
After dinner, it's green tea. It's less caffeine.
Yeah.
So hi, everybody. Hello again.
Yeah. We had a good time before, Daryl, right? That was fun. Really, really fun. We actually got to see Jupiter and Saturn next to each other without any problem. It looked great.
Oh, yeah.
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 Pretty historic.
Yes.
I had things to do, but I'm back now. Just finished dinner, actually. I'm running a little late.
It's all right. Not sure how much longer we're going to go, but I'm going to, Orion's not quite high enough to really be as spectacular as we'd like it to be. But while we're here, I'm going to take a look at this little guy. We've done this before. This little guy is called the Roper Stamp Nebula, or NGC 1999. Thanks, Farva. Wait, Marianne says, good morning, David. Is David Schmidt here? Dave Schmidt, I see you.
Yes, he is.
Hey, yeah, David, we have Daryl here. We have Carl here, host of the KGRA radio show Behind the Obsidian Curtain, Friday nights at 7 p.m. You're still at 7 p.m., right?
Yep, still at 7 p.m.,
Okay.
4 p.m. Pacific. Yep.
Okay.
That has not changed, and thank you. You are so generous.
Oh, I don't have any doubt that your show is probably one of the better radio shows there are.
Oh my God, that is
I think
such high praise. Yeah.
Well,
oh,
the people
thank
you
you
have
so
on your show are
much.
just so cool.
Yeah. Well, obviously, during sometime in 2021, I'm going to drag you back.
Oh, that's fine. But
Yeah. All right. Because I know everybody loves to hear you, and
only if no one will come on with you.
yeah. Okay, yeah, listen, if I can't get anybody else, I'll just, no. Yeah, our initial contact, at KGRA, digital broadcasting, you saved my bacon when a guest bailed. That was like about a little over a year ago, and it was like, oh my God. And so thank you so much. By the way.
Are you going to tell people what you're doing, what the other thing you're doing?
The other thing, which other thing?
Well, if you're still doing it.
Yeah.
You're still...
I don't know. Taking care of my cat. I don't know. Yard work. I mean.
No.
Oh my God. Yes. Oh my God. And I am still doing it. And I had a hitch in my get along technically, but I am. Oh my God. Through some incredible confluence of events.
Get along. Yeah. You hear that, folks? A hitch in my get along.
Yeah, it's a grandmother phrase of mine. But I am so blessed. I am doing the audio version of The Populated Universe by you know who.
Wow, when did you write that book?
Yeah, well, listen, it took me a long time, and I had a consultant named Mark D'Antonio, and I had to, check. And but no, it is wow. It is probably the most delightful challenge that I have ever had. It's yeah. And what's great is that you and I've had enough back and forth on the air, etc. I get your your rhythms, your humor, the way you wrote
Cadence.
it, that part of your personality you put into the book, and I think I get it. I mean, I hope you get that I get it. I
do. I mean, just to be perfectly clear, I wrote the book called The Populated Universe. It's about finding life in the universe. And it looks at the Earth and how life happened here from a somewhat unique perspective, right? And we talk about all the things we will talk about sometimes in SkyTour Radio or SkyTour LiveStream. But then I ended up started writing this book and said, well, I can't talk about this if I don't talk about that. I can't talk about that if I don't talk about this. Next thing you know, the book is a 350-page book. And,
oh, yes.
It's been selling on Amazon, great, and it comes in a 8x10 full color version. It comes in a little over 9x6 black and white version, and it's an ebook as well. And it's gonna be an audiobook, and that's because you, Carl, with that beautiful voice of yours, is reading the book, and she did it.
Yeah, you saw me waving my hand wildly from the back of the room.
Well, what's funny, folks, is she gave me chapter 1 that she had done, and I wrote the book, and I started listening to it, and I couldn't stop listening. I'm thinking, but wait, I know what's coming next, but the way she was delivering it was just like, it was magical. It was almost like it was casting a spell on me, and it was my own words, and it's not my words that were casting the spell. It was.
Can you see me blushing?
You shouldn't have to. I mean, it's just your cadence, your understanding about how I meant the sound, how I meant these sentences to be read. It just came out. So I was really impressed, and I just couldn't stop listening to what I already knew was coming. And it was because of the way you were delivering it. And so there's really something to be said for the delivery. And
thank you. Well, I mean, it's all those years as an actress, actor, whatever you want to label it. But also, I find the content so incredibly intriguing. So there's a passion in my delivery, shall we say.
And it shows, without a doubt. I started listening to audiobooks for the first time in my life 5.5 years ago when I was blind. And I couldn't see, so I had to do something. And so I listened to audiobooks. And it was my good friend Douglas Trumbull, who, wonderful visual effects mega god, we are not worthy.
Yes.
Who basically said, here's some audiobooks, and he helped me download the first audiobook I listened to. And it was a book about the universe, and I was like, wow, this is really great. And when you can't see, other sentences kick in, and my memory kicked in, and I was able to remember everything. It was just incredible. And then when I started to be able to see again, when I made my eyes work again, actually, then I ended up talking to other people, and basically I figured, you know what, in order to get my eyes as good as they can get, I've got to force the pain. I got to force my eyes to hurt, because you really have to really strain the brain. And I coined this thing you've heard of endlessly, and I'm sorry for saying it again, but
no, it's wonderful.
Train the brain with pain. If you have a problem, you give the brain a challenge to overcome it. And the brain is somewhat plastic. It can actually reorganize and reorient and change the locations and pathways of circuits. And that's what happened. And I didn't know if it was going to work, but it was all I had, and I had to try it. So I literally decided that as part of my therapy to get my eyes back as far as they could go, besides all the forcing myself to watch Netflix this far away that really give me migraines and everything, which got back like 60 to 70% of my sight, I said I'm going to finish the book. And I finished writing the book as part of my recovery. And so the book that's for sale now is actually the one that was the last, I'd say, 200 pages of it, 150 pages actually, of it were actually written under extreme duress, because I couldn't see the pages too clearly, and I had to really fight to use my hands on the keyboard. I dictated some of it when my hands couldn't move anymore, because I had to learn how to move my hands all over again too, remember? So I had all kinds of challenges I had to overcome, but those were just challenges, right? And so that's why the book is a labor of love, and when I see it out there, to me, the book is not the success, okay? It was the success of the process to get it out there, and then when you said you'd want to do the audiobook, and I listened to that first chapter, I went all the way back to the first audiobook I was listening to, thanks to Doug Trumbull.
Oh my.
And I was listening to your words, and they were, like I said, they were like magic, just like magic. I went back to those moments when I couldn't see, and I found myself closing my eyes and listening to you. And I thought that was really interesting, because I was like, now I'm back in that zone. And I really understand.
Oh, that's fascinating.
Yeah, I mean, I understand, how people could just get lost in an audiobook. It's really, really something,
Yeah.
So it's just really cool. So I really do humbly, love the fact that you decided to take that on. And I didn't ask you, if I recall. I think you offered.
I humbly accept it. It's, oh my God, talk about a labor of love. And okay, shifting gears here, Farva just stated, my child is on a feeding tube right now for the next 30 days due to an operation she had 2 years ago. I believe. Mm-hmm. Oh, all kinds of good energy in that direction.
Yes,
Farva, that's
absolutely,
wow.
Farva.
Oh my God.
Absolutely. And I know that the brain can fix itself, trust me.
Yes.
I came from a point where I was a quadriplegic, I was blind, and I actually forced everything to work again by making the brain think that it was going to fall down a real flight of stairs if it didn't snap into gear. It doesn't mean you should go trying things if you don't have good balance. I had people all around me, and they were really, really not happy with me. But I said, it's the only way you're going to get better. And some of them were curious enough about the technique to see if it would work. And then at one point, I got contacted by someone else who had had a similar issue. And this was a doctor who was going to lose his practice if he couldn't get his body back. And I said, I'm no doctor, but if what happened to me can help you, I'll be happy to share it. And I did. And he went away for 6 weeks, didn't hear from him. And then on one of my streams, he wrote in the chat with his own hand. Okay, he wrote, "Everything you said came true." And I thought that was just great. That was magic. See, that's magic.
God.
See, that's a testament to how our brains work. They can refix, they can rewire. Medical science has always said they can't. And by the way, this is the a nebula I was telling you about.
Oh, by the way.
Hello. Yeah, this is the rubber stamp nebula. It's just below the Orion Nebula, and it's a little tiny guy, but it's really pretty if you notice. And it's got this beautiful dark dust cloud in here, so it's really kind of cool, But
It is extremely.
yeah.
Yeah, look at that.
Daryl, how's your tea? Are you still with us?
Yeah, I'm here.
Oh, cool. You've seen this nebula before. We've looked at it, right?
Oh, yeah.
I'd like to know why it's called the 13th nebula, or the 13th. Was it the 13th? 13th pearl. I have no idea.
Me neither.
Yeah.
I've said before that Stellarium seems to have some fanciful names.
Yes, it does. Without a doubt.
Yeah, I did some Googling and trying to find out why the rubber stamp nebula was why that name, and I couldn't really find anything to substantiate why.
Well, that one's a little more understandable, because see this black thing? I mean, you know those little rubber stamps that you just stick in the ink pad and you go thunk.
Yeah, right.
Thunk,
Yep.
thunk. I mean, it looks like maybe it could be kind of sort of one of those.
Maybe? Well, sure.
Marianne is leaving.
She's going to bed. Good night, Marianne.
Good night, you crazy cop.
Oh yeah, God bless you. Take care of yourself.
Yeah, and without her, SkyTour LiveStream West would never have happened. Just so everybody knows, that's the woman who made it happen right there. She has been so good about just making sure that everything gets done. I don't know, man. You talk about someone who's loyal to astronomy and science. That's a person right there. Now that she's gone to bed, we can talk about her, you see.
Yeah, that's right. Yeah.
Hey there, Michael. How are you?
And of course, Marianne's part of Chris DiPerno's iDetective show.
I know.
On KGRA Digital Broadcast. Yes, and a great part of it.
And when is that now?
You're going to ask me a hard question. I believe Thursday, and I can't tell you the time.
Marianne, if you're still on, please just plug your show. It's a radio show by cops, about cops, for cops. It doesn't mean you can't listen.
No, and the deal is the insight. I mean, Marianne she just on the last show, which I guess was yesterday. Anybody in chat know the exact time so that I don't have to leave and try to find it? But it's sort of like she calls it out. She says it in such clear terms, what officers are facing. And when someone pulls a gun, they can't say, time out. What kind of gun is that, sir? Excuse me.
Is that a real gun?
No, they just have to do what they're trained to do, right?
Thursday,
she
6
says
PM.
there she is. Thursday, 6 p.m. Eastern for iDetective.
Yep, that's great. That's right. And she brings an awful lot of knowledge and excitement and passion to that show.
Yeah, she gives it heart.
Yep. I went for a ride along with her in her police car when I was in Arizona. I think we were 10 hours on the road with Marianne.
Oh.
And it was the most boring day I've ever had. Absolutely nothing happened.
Well, I guess in a police officer's day, that's a good day.
She was bored. She said, "Why can't I pull my gun?" No, she didn't say that at all. I'm kidding.
Why can't I tase somebody?
Yeah, no. Well, no, she's always threatening to tase me. That's the thing. She goes, "I'll tase you." I go, "Okay, don't worry. I won't make you tase me."
She teases with the taser.
That's right. She's a taser teaser?
I guess you could say that. In fact,
Teaser
you
of
just did.
taser.
Yeah.
Teaser.
Yeah. Oh, and she says that a pre-record for next Thursday, Christmas Eve. Yeah. Like I pre-recorded my Christmas Day show on Monday. Yeah.
What?
And Marianne says, "Hey, traffic accident." Right?
Yeah. That's funny because as part of my recovery, okay, my left foot is numb, and so when I try to run, I go boing clump, because my left foot is like, numb. So what happens is there's a traffic accident, and she yells at me, "Come on, we got to get in the car!" And I'm about 30 feet from the car talking to one of her friends about telescopes, because then we went over his house later to work on a scope. But I had to like run to the car, and I had yet to actually get those muscles back. I was still working on them. So I'm running to the car, and I really kind of look silly, and she's been laughing at me ever since. Thank you, Farva. We've missed you around here, Farva. I'm glad you're back.
Yeah.
So yeah, give me a laser teaser. Taser teaser. All right. That's right. And can you give me a taser teaser? Oh, the one with the lemon, or you want the lime? Oh, the lemon, please.
Just a lime, please.
Okay,
right.
all right. One lemon taser teaser, please. Whoa, okay.
What would be
Here we
the
go.
ingredients? Now that's an interesting thing.
Well, lemon.
Right. Or
and,
lime.
And what's the teaser? I guess probably some kind of alcohol of some kind.
Or maybe the teaser is there's no alcohol at all.
But maybe the
Amperage. Lots of amperage.
amperage. Yeah.
Lots of
Yeah, that's funny.
yeah. Or what's that fabled drink? Where you drink it and you see the green fairy, and that's not the case at all. Back to France.
I have no idea what you've been drinking about.
Absinthe?
Absinthe. That's it. Absinthe. About which the joke was made. Absinthe makes the heart grow fonder. Yeah. It's sort of it has an anisette, kind of a licorice sort of a flavor to it.
I'm
I
absent
was
of any
gifted-
idea what that is.
Yeah. Well, it's a fabled liqueur, and it's just, I don't know. It was supposed to make you hallucinate and see the green fairy, and so there's
Really?
legend and lore about that. Back from, I guess,
Okay.
18th century France, perhaps.
Okay.
Yeah. So
just
moving right along,
Don't
but
know
yeah.
what that's about.
Yeah, no, it's much ado about nothing.
Oh no, it's much to do about something. I just don't know about what amount of something. If it's more than just nothing, or if it's nothing plus one, I don't know.
Isabella said absinthe is terrible. Yeah, yeah. And Ginga says maybe this drink we were talking about, the taser teaser, maybe like a lemon drop martini. I don't know what that is.
Well, see, you got to
but-
come up with a taser teaser now, Genghis.
Yeah, there we go.
Yeah,
Gingus's
Yeah.
book of drinks.
that's
I
right.
guess it would be voltage, not amperage.
Oh yeah, got it. Yeah.
Yeah. Is there any drink that actually sounds like amperage or sounds like voltage?
Is there something called amphora? Or
Uh,
I don't know. Some ancient.
Well, an amphora
Something
was
of-
a container, right?
Amphora.
Right, those are the little glass containers, right? Right.
clay, yeah.
Amphoras were the jugs that the Romans and the Greeks used.
Ah, okay, and they kept some sort of liquor or something. Tara says, "Are you making something of nothing?" Yes, I think that's exactly. I think you nailed it there, Tara.
Well, we're
Yeah.
making something out of nothing. That's the whole point of something.
Ooh, now we're talking alchemy.
Ooh, that's right. Alchemy is really fun.
Who is that guy? Al Chimi. He's a stand-up comic, right?
Yeah, right. Yeah, but he's not what you think. Brum-bum.
Yeah. Get your drum set up there.
Hit the moon, right? That symbol that's supposed to ring, right?
Right.
Mhm.
And Isabella throws in ambrosia. Oh, nectar of the gods, ambrosia. Yeah. Mm.
I've never had it. I don't even know what it is. I heard of
Well,
it.
the ambrosia I know, my mother actually would make, but it's a fruit salad kind of a deal without any kind of liquor in it. Yeah, Daryl says, Isabella, popular among the 19th century artists and such. I think, are we talking, maybe we're going back to absinthe? I don't know. I think we've just about run this into the ground. Genghis says, Jolt Cola.
Yeah, well, there you go. That could be part of the taser teaser drink.
Yeah, there we go.
You know, like rum and Coke,
ingredient.
rum and Jolt.
There we go.
Gosh, can you imagine that? You'll be tased on your butt with that, but no time.
Right. In fact, with that, you probably don't need the taser.
I think you're right.
Yeah.
This is a close-up of NGC 1977 here. That beautiful little nebula with the tight narrowband filter. You can see there's a lot of convolutions and detail in it, which is really interesting. I'd like to pull out some more.
Ooh.
So what I'm going to do is I'm going to drop this down 2 stops, but I'm going to go up to a minute and just hang out with this at 12,800 to see what I can get. All right. So this should be a little bit brighter and less noisy. We'll see what we get. Farva, you know, you've been very generous to us, Farva, and you're a real friend of the show. I just want to make sure that everybody knows that. Thank you. I mean that. Thank you.
Indeed, Farva rocks.
It does. Farva rocks.
Yeah, I was just thinking how interesting it is that we call this visual stuff, you know, astronomically noise. You know, it's that overlap between, you know, we talk about, we use the phrase, it came up on my show today, radio appearance. Like, wait, what? We're mixing the, you know.
That's like plastic glass.
Oh, that's good. Oh, that's even,
not mine.
That's even better.
Well, it's business ethics, you know.
Right.
Military intelligence, you know.
Right, yes. Oxymorons. Mm-hmm.
Jumbo shrimp, remember? Carlin?
A jumbo shrimp. That is the best. That is the best.
It's like, jumbo shrimp. What's going to arrive? A little jumbo or a big shrimp? I don't know. I like how he does that.
All right, wait and see. Farva says, Farva wants you to address the incoming debris field. Jupiter? I don't know what that means.
I do. Okay. Farva, actually, there's no debris field incoming. I mean, you know, a lot of things on the internet get legs that shouldn't.
Yes.
And we don't have to worry about any debris field heading toward the Earth. What we have to worry about is the errant asteroid that might be coming here. But we actually have a methodology for dealing with that, and it's called the Sentinel program. We have a way to deal with incoming asteroids that will allow us to have some notice that they're heading our way. That notice could give us a year or 2 years, preferably 3 or 4, and we could then use that time to develop a way to deter, gently persuade an asteroid from striking us. And that's something that is very important. And so the Sentinel list is a list of objects that are a threat to us. Every object that's found for the first time goes on the Sentinel list if it's going to be like a comet or an asteroid. If it has unknown orbital characteristics, it goes on the Sentinel list. Then as the characteristics of the orbit are determined, most of the objects on the Sentinel list end up being taken off. And I know the word most isn't very comforting, but most of those objects do get removed from the Sentinel list. And the ones that stay on, right now, the only ones that are on there because of the fact that there is some question about the completeness of their orbital elements. Many of these things are far away. You know, they don't sit there for years when they're an inner solar system object that could be zipping by us, going between us and the moon. We've had some of that too. We've had asteroids that are, well, I wouldn't even say asteroids, they're like big meteors, like maybe about 3 feet across, that have gone between the Earth and the moon, actually have come within like 1,100 miles of the Earth. clearly the Earth's gravity has pulled them in, But, people say that, this thing right here keeps us safe, this moon. They say, oh, the moon keeps us safe. Actually, I beg to differ. I think that if the moon wasn't there, I think life would still have developed here. But then you'll say, well, the moon was responsible for the tides, and the tides generate, these tidal flats on the ocean, and that's how creatures learned how to stay out of the water for a longer period of time. All true. And that's all true. But the moon isn't the only source of tides, and Daryl knows what the other source of the tides is, and we've talked about it before. Daryl, go ahead.
The sun?
Yeah, of course, and so Daryl, I picked on you with that one. I picked on you, Daryl, because we talked about this before, not before today, but on the radio show, and maybe you don't remember, but you're absolutely correct. The sun.
I remember.
Yeah, the sun generates tides, but they're only half as much as the moon. So, in the Bay of Fundy, where the tide can go out for about 20 or 30 feet, I think, they would only go out for about 10 or 15 feet. But it's still going to go out because of the sun. All right? And it's going to be the same frequency because it's tied to the rotation rate of the Earth. So we would still get tides, so we would still have life. So why would I say that the moon being around us is causing us a problem, or could be causing us a problem? Because it's another gravity well. It's another source of gravity that pulls these things in. And it's pulling in these errant asteroids to the pair of objects that is the Earth and the moon. Yes, Earth has a lot bigger mass, but the moon is 1/6. So that's significant. It's not a 25th. It's a 6th. So it's actually pretty big. So together, the reason the moon might have so many craters is because of the Earth-Moon pair. And the reason the Earth got pelted so much is because, potentially, of the Earth-Moon pair. And not the fact that, there was just a lot of asteroids flying around. I think the Earth-Moon pair drew a lot of those things in to our neck of the woods and caused a lot of the impacts. So if there was no... Daryl. Daryl has CRS. That stands for
can't remember stuff.
Right. Yes.
Yeah.
Yeah. Well, that's better than going through special high intensity training, right?
Sure.
Right.
Yes, it is.
Special high
What you
intensity.
were talking about a minute ago, there may still be a group up in the high country here in Colorado, ski country, if that tells you anything,
Vail.
called Planetary Defense.
Oh, yes.
They were deadly serious. They were
Really?
a kazoo lawn chair marching band.
God, I love
They
it.
performed at all the local parades.
That's wonderful.
Kazoo
Yikes.
lawn chair on floats with lawn chairs.
Lawn chairs.
So did they what?
Did they put
the
lawn chairs on
were
a
like
float?
stationary, or how to? Yeah, float.
Well, they carried lawn chairs, and you know how parades would pause.
Oh,
They would
okay.
flop down the lawn chairs.
Yeah. So they'd and play their.
Play
Do you
them.
remember what musical what the tunes were, Daryl, on the kazoo?
Not off.
Anything
not
they could
offhand.
hum, I would imagine. I guess so.
Yeah.
That's kind of
Or-
funny because if you think about it, I thought what Daryl said at first was the kazoo launcher band. And I'm thinking, how do they launch these kazoos? And lawn chair. Okay. He said
Yeah,
lawn
right,
chair, and I
yeah.
heard it like he was throwing in some kind of an accent, and he was trying to say launcher. But he doesn't do that. So I was like, well, that's odd. Why would he say it that way?
No,
But he was saying what he meant, lawn chair.
Yeah. Like law enforcement doesn't mean you have to go grass anywhere. It means, law enforcement, right?
Yeah,
Okay,
it doesn't mean you
enough.
force grass to grow. Law enforcement.
That's right. Now Farvo says, he asks, doesn't the United States and Russia, as a combined force, have a variant protocol to eliminate such probable incoming dissidents, as in like debris, junk?
I would like to believe that's true. We do have a Space Force now, and, before
Yes.
you laugh at it, the Space Force, which I was actually considering applying to be part of, I was because I know what it does. I know what it really does.
Yeah.
The Space Force is meant to, in part, deter potential asteroid strikes. And it's also meant to protect satellites in orbit. And that takes it down a dark, black project type path. But I was more concerned with the Sentinel list management and elimination of Sentinel objects that might actually pose a real threat. Now, we know what a little tiny asteroid can do if it strikes. We did a radio show, SkyTour Radio, and I actually went through various things and calculated the effects of the impact of an iron object 50 feet across, 100 feet across, 200 feet, etc. Landing in the ocean, landing on the land, what would happen? How big was a tsunami? What would happen to buildings? What would happen to people? What's the long-term prospects? And the bottom line is that, there is a lower point, a lower level threshold beyond which you don't have to bother. If an object that's going to hit the Earth is about 20 feet across, let it hit. It's not going to do any real damage to the Earth. Okay, it's not going to. Most of it's going to get destroyed in the upper atmosphere. That's like what happened at Chelyabinsk in 2012. Now that injured about 1,000 people. Didn't kill anybody, but it injured about 1,000 people with broken glass and flying.
Yes.
I mean, metal security doors bent in half from the shock wave when they're face on. I mean, we're talking about this is because of the atmosphere. If there was no atmosphere, well, we wouldn't be here, of course, but if there was no atmosphere and this happened, say, on the moon and you were at a moon base, it would strike, you'd feel a rumble, and that'd be the end of it, and then maybe you'd get pelted with some debris, but you wouldn't have what's called an overpressure, the shock wave. You wouldn't have a shock wave that would hit from the wind, because the wind from these impacts can be hundreds of miles an hour instantly, and that's enough that's like taking a straw and putting a little pile of powder on the table and going through the straw. Is that powder going to survive? I don't think so. It's going to get blown all over the place, okay? And that's the instantaneous effect of these very high wind streams. They will shear you into pieces, actually. You think a tornado is bad.
You might remember I mentioned during a SkyTour radio episode a while back, they found evidence of a site over in the Middle East, Syria,
yes.
I think, where there was evidently a cometary explosion in the atmosphere.
Yes.
And it incinerated the entire village.
Yep.
Thousands of degrees. They said it hit like 4,000 degrees Fahrenheit there. And
yeah.
They were finding glass shards embedded in the remains of people and all sorts of stuff.
In the buildings. Remember, they're melted to the buildings. Remember that?
What's the timestamp on that, Daryl, roughly?
It was thousands of years ago. That's
Yeah.
all
Yeah.
yeah.
Hey, Farva,
And-
thanks, man.
And then we have Tunguska.
Yeah, Tunguska, that explosion, obviously, it never had an impactor that reached the ground. So there was an airburst explosion. So whatever it was probably low density. And that's why you see a lot of theories that it was a comet. And you say, well, why would such a low density object not just melt and dissipate? Because of the speed it's moving. It enters the Earth's atmosphere and it comes in at such a speed that as it enters the atmosphere, it's going down through the atmosphere, and more it's feeling the pressure on it as it's going through the atmosphere, and the atmosphere is getting thicker and thicker and thicker as it's coming down. Its speed is not changing very much. It's being reduced a little bit, but there comes to a point where the ability for the material, the object to hold together is overwhelmed by the atmospheric density at the speed the object is traveling. And the thing to keep in mind is that we'll say velocity, okay? The velocity that this thing is traveling, okay, the velocity that they're moving can be like many tens of thousands of kilometers per hour. So if it goes from 5,000 to 3,000 kilometers an hour, okay, That's not a lot of a drop, okay? But in that time frame, it's dropping through an awful lot of atmosphere very quickly. And as it does so, that speed translates to what we call kinetic energy, right? And that kinetic energy is the energy of motion, and that energy of motion is getting converted to something else as it hits this wall of atmosphere. And when it finally hits that wall and explodes, all of that energy of motion is converted into the only other thing that it has, and that's heat, okay, and a shock wave. And that energy transformation, when that happens in our atmosphere, it translates to a massive shock wave that's very high temperature, very high pressure, and very high speed. And so it moves in all directions, and it moves radially out from the impact point in the atmosphere where it finally explodes, and that can flatten the forest below like Mount St. Helens did. Hard to believe that all those trees were flattened by the blast from Mount St. Helens, but they were, okay? And when the object explodes in the upper atmosphere like that, it can be miles up and still flatten large, mature forests with 14, 24-inch diameter trees like nothing, like toothpicks, And that's the overpressure. That's the pressure equation thing going on there. So this is the kind of thing that we would want to avoid. Back to Farva's question. And Russia and America don't have technology in place, that I know of, okay, that can stop such an impact. As a matter of fact, most of the things that strike us, or that might strike us in the future, I have to say, are things that we didn't see until after they got past us. So that's not very comforting, is it? However, in all fairness, those are usually the smaller objects. The bigger ones that are on the Sentinel list, as we refine the orbital elements of these things and the orbital characteristics, then maybe we would maybe we'd feel that we'd be more comfortable taking it off the list. But it's definitely not a pleasant thought to have that happen, because there's nowhere on Earth really where we can end up getting struck by something that isn't going to have a far-reaching impact on the rest of us. Because in the analysis I did, even if an object struck on the other side of the planet, okay, what's interesting is the shock waves, the way they travel through a sphere. The shock waves would travel, let's say it hit directly on the opposite side of the planet. You say, oh, we're safe. We're all the way on the other side. Well, the shock waves would go right through the planet. And like a croquet ball, a massive shock wave would come out from the exact opposite side. So if it struck here, you get boom, from the other side, from the shock waves that have passed through. In fact, the moon has some impacts on it that show a similar type structure, So it's not a foregone conclusion we'll never get struck, but it is a foregone conclusion that we really will be in the future if we're not careful.
And am I correct that also would impact oceans and send huge tsunamis at least?
If it hit in the ocean, yes. Actually, the types of strikes that might be the safest for us, if you want to say that, might actually be land strikes. Unfortunately, land is populated. So maybe if it hit like the central northern Canada, Siberia, northern Siberia, then maybe it would be okay. But the land strikes, they put dust into the air, vast amounts of dust. But at least with the dust, that's going to have it's going to have a snowball effect over time. Creatures that feed on plants are going to die off, because the plants are going to die off because the sunlight's going to be thinned because of the stuff in the air. And then we're going to have problems of food shortages. Then we're going to have problems of power shortages because everyone's going to be using lights and electricity because it's going to be dark during the day. And, cars won't work right because, not for electrical reasons, but because of the dust getting into the engines. There's going to be a lot of stuff we have to worry about like that. So, but...
Hey, Mount St. Helens were in the windshield on my car back in 1980.
Oh, yeah, that stuff's like glass.
Oh.
Probably had fine scratches all over your windshield.
Oh, yeah. Like an idiot, I turned my windshield wipers on.
You weren't an idiot. You were one of millions who did the same thing.
Yeah.
And the insurance companies went, oh. But that's fair. You weren't an idiot. You didn't know any different about it at that point. But like lunar soil, Mount St. Helens ash is extremely coarse. It's like little glass. I've got a jar of it upstairs. And just from being in the jar, shaking it, over the years, it's actually scratched the jar. So now you have to open the jar to see it because it's cloudy now.
Wow.
Which is, you shake it and say, look at this Mount St. Helens ash. The more you shake it, the more you're scratching.
Yeah, a little disclaimer. Well, strangely enough, somebody took some of that ash. I was gifted with a mug, a coffee mug, that was kind of swirly looking, and who can substantiate this, but it supposedly, some of those swirls in the ceramic were made from Mount St. Helens ash. I don't know.
I actually have a duck upstairs that was made from Mount St. Helens ash.
Oh, really?
It's just big.
Yeah.
Yeah, it was cast in Mount St. Helens ash. You know what's funny? The ash, like in your wood stove and stuff like that?
Right.
That ash is actually, people throw it away. You shouldn't throw it away. If you have potholes in your driveway, you go pour it in the potholes, and if you add a little water to it, it actually becomes like concrete. It's actually a very useful substance. Yeah, it really is. And that's...
they say volcanic ash was the secret to why Roman concrete was so strong.
No doubt. And volcanic ash, like Vesuvius volcanic ash, Pompeii, that volcanic ash, you saw what it was like to dig the remains out of Pompeii.
Yes, and there have been some new discoveries of that.
That's correct.
In the last couple of weeks, right?
Yeah.
A man and his slave.
Yeah.
It's terrifying. It's wonderful when you on a human level, though it is so distressing.
Yeah. It is, because you can't imagine going through that, but you have to imagine that you're living on the slopes of a volcano like Mount Vesuvius. You didn't have any technology. You thought that by bringing fruit to the base of the volcano and food, that you appease some god. And it's like, I know in Hawaii they do it, but you know what? There aren't really any Hawaiians that, I don't think, that really believe that throwing vodka and stuff, into the lava is going to appease some god. And I think that it's more of a ritual and cultural thing, and for that, I admire that, actually. My mother being Native American, there were Native American traditions too that wouldn't make any sense, but culturally they were kind of cool. So, and that's why they're exciting. But but back then people didn't know any different, and like, for instance, I'll give you an example. If it had to do with gods, then the gods are strange and fickle, and their solutions to problems and their results are not often understandable. For instance, one of the very few survivors of the Martinique volcanic eruption that wiped out the entire city, on that island. I'm trying to remember the name of the town. I was there. I actually walked through that town. I was curious to see what had happened there. I wanted to go up to the Mount Pele to see the beautiful Emerald Lake, but on the way up the road was washed out and couldn't go. But I had wanted to see it. But in going up there and going through there, I actually went into the prison where the prisoner who was being held for drunken and disorderly conduct overnight was the only survivor. And he had the burn marks from the bars because it was such scorching heat from this. It was called a Nui Ardon. It was a pyroclastic flow that came roaring down the side of the volcano at 100 miles an hour.
Yep.
killing everybody in the town except for him, because he was inside a concrete enclosure with just bars through a window. And when he looked out the window, the scorching heat burned the imprint of the bars, the shadow of the bars, onto his chest. And he fell down thinking it was the end of life, hell on earth. And he went on to tour with the Ringling Brothers and Barnum and Bailey Circus as the only survivor of the volcanic eruption.
Oh my God, that was Mount Pele, right?
Yes.
Yes.
Yeah.
Wasn't there a movie about that? Spencer Tracy. I remember that made a big impression on me when I was a kid.
Yeah, I think so.
Not The Prisoner so much, but the Martinique volcano.
Yeah. I'm trying to remember the town. I keep saying Eligius, but it's not the town in Elmo, but it's not the town. Anyway, someone in chat can look up the Martinique city destroyed by the volcano, and you'll get the answer. And then put it in chat in like 10 seconds from now, I guarantee it. Farva, I want to thank you, by the way, for all your contributions. You've well above and beyond. You're the man. You're great. Thank you so much. It's great to have you back, too.
Did you ever see the movie Joe versus the Volcano?
You read my mind there, Daryl. Yeah, hilarious.
Yes.
That's my favorite Tom Hanks movie.
Yeah.
They really run with some stuff. But before you go on, is this the 1902 eruption, Mark? It was the town of Saint-Pierre.
Saint-Pierre, that's right.
Yeah, it
Martinique.
killed according to Wiki, it killed 29,000 to 30,000 people in just a few minutes, considered the worst volcanic disaster of the 20th century.
Yeah.
I'm just going to pop that.
Saint-Pierre is right. And then, Marco, you're funny. And then, I couldn't remember the name of the prisoner that survived, that one guy that survived. This is Betelgeuse, by the way, for anyone who's interested.
Oh my God, look at that.
Yeah.
In all its red glory.
Yeah,
wow.
It's beautiful. I'm going to try and go back to a setting here. Oh, good, it remembers. I want to try and remember. Let's do this again. I want to see if the new color correction settings work on Betelgeuse. Betelgeuse should look more orange now, if it works. There we go. Yeah, that kind of worked. Look. So now I'm using a filter, right? The narrowband filter, but I added color corrections into the sensor, so I get back the regular color of what it really looks like. So this is really what Betelgeuse looks like. Beautiful orange. I no longer have to worry about this being more purple now. Yeah, that's good. Very nice.
Very nice. And just to put a cap on it, if you will, apparently the name of the man who survived that eruption, according to Wiki, is Ludgar Silbaris.
And what was he in there for?
Lugersylbaris, who was born June 1st, 1874, and died in 1929, an Afro-Caribbean man who was one of two survivors in the city of Saint-Pierre on the Caribbean island of Martinique during the devastating volcanic eruption of Mount Pele. And that occurred May 8th, 1902.
Yep.
Yeah.
Silbaris toured with the circus after.
Yes, it says Silbaris was pardoned of his crimes. It's above in the paragraph. I don't know why he was in the slammer, shall we say, but he pardoned of his crimes and later joined Barnum and Bailey's circus touring America and recounting the horrors of that explosion. He became a minor celebrity in that process. They called him the man who lived through Doomsday.
Mm-hmm. And he did.
Yeah.
You can't take that away from him, but I'm sure he wishes they could.
Oh, indeed.
That was just a horrible situation. I mean,
right. It says here that he was still trapped in that rubble of the prison for 4 days.
And it was hot. It was hot in there, and so he was sweltered and sweltering heat too. Yeah. He thought he wasn't going to ever be rescued.
Yeah.
The movie I was thinking of was called The Devil at 4 O'Clock.
Oh, yes, I love that film.
1961, I think it was Spencer Tracy.
So that was when Spencer Tracy was it Martinique and Mount Pele?
Yeah.
Yeah.
Okay.
Oh, one more interesting note that I just can't back away from.
Yeah.
In some accounts, Ludgar Silbaris said he had a precognitive dream, and he was locked up as a drunk because when he spilled that dream, he caused a riot. Oh my gosh. Okay, well, so sorry here to go there, but
Well, that's what I thought. It was drunk and disorderly is why he ended up in
well,
jail.
drunk and disorderly because he told people about this precognitive dream. I just had Preston Dennett on the show, and one of his anecdotes was a woman who had a precognitive dream about a volcano eruption. So I'm sorry, but like, oh my God. You know, sometimes this stuff overlaps in the most peculiar way, doesn't it?
Yes. Yep. It's overlapping in the most peculiar way.
Yeah, that could be a song. Yeah, so yeah.
I'm just focusing right now to
Yes, please. Back to the matter.
I mean,
at hand.
focusing physically, focusing the telescope. Yeah.
Sorry. It's Friday night, people.
It is Friday night, and I'm
okay.
just now I'm thinking about Joe versus the volcano, which is hilarious. If anybody out there hasn't seen it, try to watch it. It's hilarious.
Yeah. If I remember right, Abe Vigoda, the guy who played Fish on Barney Miller, he was he was the chieftain. They all drank orange soda.
Orange soda, right? And
Tara
remembers. And the orange soda can, it was like what, a bunch of it washed ashore or something, and
it became like a manna from heaven type thing.
That's right. Yeah. Chad is enjoying this. Tara. Okay, as she told me so that I could remember it. Tara on dotted line. Okay, so Tara. Yeah, and she says, "Woohoo! It's Friday." She also says the big word coincidence. Yes.
That's difficult territory to get into, though.
Oh my God! Okay, you said it. I didn't. I'm backing away. I'm laughing, but I'm backing away. That's hilarious.
I've taken the telescope over to the Rosette Nebula right here, where we're going to try and check out this beautiful nebula. And again, I'm moving into the murk a little bit, but I haven't learned my lesson. What can I say?
Now,
let's see how it looks.
The man who makes his way through the murk. Mark.
Yeah. Mark of the Merc.
Perfect.
Yes.
Murky Mark.
That's it.
Yeah.
So tonight we can see with the regular wide narrowband rather, it doesn't look all that exciting. But when I look in here,
but wait.
We go back to narrowband 1 and let's increase this to a minute and watch. It will look very different. We'll be able to see some of the details in here. It is actually kind of a bad night. It's clear, but it's actually not a very transparent night. The transparency is poor while the seeing is moderate.
Do you have a lot of humidity at the moment?
Oh, no.
Oh, good.
No. It's all on the ground now in the form of snow.
Yeah. That stuff called snow.
It's the stuff called snow. There you go. I'm telling you, I hate it, don't you know?
Whoa ho.
I want it to go.
You said you got like 15 inches, didn't you?
Yeah.
Oh my God.
I did.
I think it was Syracuse, New York, got like 40 inches.
Oh no.
I put on my nice little LL Bean fuzzy shoes, I said, these will be good. I step out in the snow, and the snow goes up to my hips. It was a drift. I was heading to get the snow shovel in the shed.
So you were adrift in the drift.
Yeah. And have you ever actually tried to walk out of a snowdrift?
Yes, I have, and it's sometimes depending on your shoe stays in the drift.
Yeah, it didn't happen this time. When I was in Norway with Kat Torvaldsen, we were up in the Bergen woods with the police looking for a woman's body of all things.
Yes.
And look at that, beautiful. See that? Now this is what you're talking about. See, the filters had such a different look. Okay, you can see all those
Oh,
dark
my.
lanes. See that? Beautiful. Really pulls those out beautifully. Here's the nebula. And I stuck my shoes down in the mud because there was mud. It was a swamp. I didn't know that. And boom, I pulled my shoes out without my sneakers. Or I put my feet out without the sneakers. You know, they had to take me to get shoes, which is very nice of them. They did.
So are you saying that you contaminated a crime site?
Actually, if they dig down, they'll say, "Who was this guy? This is the guy that did it.
Oh no.
He's the one that's guilty. This one right here. This is the guy that did it."
Well,
Yeah.
we'll all testify for you.
Yeah.
Yeah.
Some of you won't.
Yeah.
So you
I want
see-
names. Who are those people?
Yeah, right? So look at that. So now that's what you can see what these filters are good for now. You see these beautiful dark lanes. They show up. Look at that, Daryl. You know,
Yeah, I see that.
you know, again, color correct as we might. This is what we get, you know, and you can color correct later, but now you see the beauty of, say, like the Hubble palette. When they use the different colors in the Hubble images, that's not what those things are really looking like. You know, but they use colors that show the differences between things, and this is an example. Now I've changed it to the normal color palette so we can look at the difference. You know, it's been like 4 hours and 16 minutes here. Holy cow, we going to town.
Wow. Time is just speeding.
I know. Well, I started early.
Yeah, that's
you know,
right.
You know,
Yeah.
so I mean, it's, yeah, see.
Yeah, it was like, you know, as I said to Amanda in Skype, wow, this is like a break in the space-time continuum.
Yeah.
Starting this early. Wait, what?
Yeah. So look, so this is the shot now, right? This is with the automatic colors, as we've said, and I was still correct for color. But now look at this. Okay, this one you can see these lines much clearer. See, and it has to do with the way we're using the color. You come in here and look, and the lines are a little bit more muddied. They're kind of they're a little more hidden. The contrast is better here. And so this is why you use different colors to do the work for you. And it's too green. Okay, so I would want to, if I were to come back in here, I would actually change this. Probably let's do that. Okay. Go shift it toward that direction. Now if we do another shot, we'll see a difference yet again. This is the old shot. This is the one we just took coming up. Okay. And then we'll see something a little bit different.
Back in the days of film, I captured the rosette once next to Orion, the constellation, with ASA 400 film, a 15-minute time exposure shooting with the camera piggyback with a normal lens on top of the telescope.
Yeah.
And it just popped out beautifully.
It does.
And it's that hydrogen red color.
Yeah. Well, that film you're using was probably had a good red response, as they say.
Yeah.
What were you shooting? Do you remember?
I'm sorry.
What film were you shooting with?
No, I don't know. Probably Fuji 400.
Oh yeah, Fuji 400 was well known. Okay, here you can see that the green is slightly less. It's more of a greeny blue, and the details are still there. Really quite beautiful. So like it's nebulae like this that you just can sit here and experiment with, and just go to town to figure out exactly what you want to do. And that's, let me take us, let's head up here.
Best I ever saw it, I probably mentioned before, was through that 13-inch Daba. A guy I knew had a hydrogen beta filter on it,
Yeah,
and it looked just like pictures, except it was gray instead of pink.
yeah. And for those listening, when you look at something in the eyepiece of a telescope with your eye, you'll never see it in the colors that we see here. And Daryl's alluding to that now, because your eye has rods and cones. The rods are on the outside of the eye, and they are black and white receptors. The cones are in the middle, and that's what we've evolved to be able to see in color where we're looking at direct vision, looking right at things. But when you looking at something dim, the cones don't get fired. Only the rods get fired. The cones need a lot of light. It's an evolutionary quirk. And so without the light, when you look at something that's relatively dim in an eyepiece, you're not going to see color. So that's why the Orion Nebula still looks like it's black and white, but it might have a tinge of green. You might be able to see it as a little bit of green, because those parts of the nebula might actually show up. Barely. You know? I think you talked about seeing it as green too, Daryl.
Seeing what in particular?
Orion Nebula.
Oh, yes. It always looked greenish to me. In my mind's eye, it's green. I said once that I got to look through a 10-inch f6 refractor once.
Wow.
And we could actually see hints of green and red in the nebula.
Wow.
It was larger, very expensive, not German, but it was Russian optics, I think. It was sold by Marcus Ludus, the German telescope guy.
Yeah.
It was just a tremendous view, and you could actually see a little bit of red in it too.
Yeah. Farva, tell me what you're talking about.
Yeah.
So I'm taking another shot now for a minute, but I've upped the exposure by 2 full stops. Because you get to a point where you start to see the color coming through. It's the same type of process. If there's not a lot of signal, then the color is muddy to a camera sensor. You have to have more signal. So a longer exposure or stacking lots of exposures can actually pull out more detail and more color. All right, because it's color, but it's very faint that you can't see and that the computer monitor won't show. But all right, so here we've gone a little longer. 2 stops, still didn't cut it quite, but we could try and go into the settings, go into the bulb shooting. We're at a minute right now, and we can say 1 minute and 30 seconds and say okay. And now we'll increase this even more, go to 80,000 and go to 1 minute and 30 seconds and see if the color starts to show up. Like I said, if it doesn't really matter, because we can make it show up later. We can make it come out because it's there. It's there. Oh yeah, remember Photo Hut David Schmidt?
Oh,
remember 1 hour
Hut.
moto photo? 1 hour photo?
Yeah. Yes.
I used to bring all my photos down there to get taken care of. And I did a nature photo shoot down in the Everglades. I was in water up to my neck with alligators and photographing them from the water level, right at their level, moving through the water slowly right next to them, getting them to turn toward me by tossing pebbles on their back, and they'd tap and they'd spin around, and they spun around and I would take shots. You know, they were far from me when I did that. They were like 20 feet away. And when I did that, I actually, again, shooting film, I went through rolls and rolls and rolls of film. I mean, so many rolls. And I brought like 26 rolls to this photographic place to get shot, to get developed. And they said, oh, this is going to be great. Yeah. Except that they ruined all 26 rolls.
Oh, no.
Yep.
Oh, my God.
All 26 rolls. They had a problem with the chemistry.
So that means corrupted negatives and everything, right?
Yep. And so I was blown away, and they said, well, we can offer you a free film.
Yeah, thanks a lot.
Yeah, no, I didn't. It didn't go too well, and I was actually rather belligerent. And I banged so hard on their glass counter that I broke it. It was a glass case, and it broke and smashed into the camera gear inside. And I was like, oh boy. And they said, well, maybe you should just better leave. I went, you're right. And I walked out, and I was mad for probably 2 weeks. Now, on this shot, you can start to see, look, there's a little bit of the red coming through finally. See? So you can see that the color does come through eventually, and it's starting to peek through with a 1.5-minute shot. And there's some up here, okay? So we're right at that threshold. And if I take us up to, say, 102,400, now let's even go higher, 128,000. Let's see what a 1.5 minutes at 128,000 brings us. Now, it's bringing us lots of noise. I don't mind telling you. Look, lots of noise. Okay, stars are noisy. But we also are getting this beautiful convolution here. We're also seeing, some of the red. Again, the red is there. This color, this stuff here, this cloud, is red. And I can correct for that and bring it out. This is just trying to show you. Okay, this is the cluster that is the progenitor, the source cluster that has illuminated this nebula. This nebula is shining in the light of glowing hydrogen. Okay, so it's a H2 region, or an ionized hydrogen region. Okay, and so it's causing all this to glow, and these dark lanes are dust lanes that are circulating all throughout here, this whole area. It's just beautiful, a really, really beautiful location. And as Daryl said, he's seen it looking gorgeous in the telescope. I've never seen it with my eye. I've only seen it in the cameras. I've only seen it through the eye of SkyTour LiveStream. Same with the Veil Nebula, which is the supernova remnant in Cygnus.
Oh, for the good old days.
Yeah. Alright, so let's see now if this area here grows in size. If we see more red. There's some red up here, you'll notice. Oh yeah, look at that. Okay, now we see there's some red here. This red is much brighter. Okay, let's just process a little bit here. There we go. So this red is brighter. So you can see, okay, there are areas where the red is starting to really pop. And those are some of the brighter areas. But we're also losing some of our dark lanes. So we're actually a little bit over the exposure. See this? Now we see the dark lanes pretty well. We don't want to go too much brighter and too much longer and too much higher in the sensitivity. Really, I think one of the best shots is probably this one. And if I were to take 25 of those, I'm not going to do that to you, but if I was to take 25 of those and stack them, we would have a really, really pretty image of this part of the Rosette Nebula. It goes all the way down and around too, by the way. Okay. So it's a cool looking nebula, that's sitting out there. And it's, as Daryl said, it's just to the left of Orion. I'll show you where that is. Okay, there is, let me just get rid of it here. Okay, there we go. So here is the constellation of Orion right here. Let me give you some constellation lines to make it easier. Okay, there's the constellation of Orion right there. Right below the belt of 3 in Orion, there's the Orion Nebula. To the left of Orion is Monoceros, the unicorn, and this right there is the Rosette Nebula. And I think I was gonna stop at that. I think I want to go see now this the Hubble's Variable Nebula. And Daryl and I have talked about this many times with you all. We look at this nebula, and we find that the nebula sometimes looks very much like it's changed a little bit from the last time we saw it, and it actually has. It's a variable nebula. It does change, so we want to try and see if we can register any differences. So right now we're heading to another star to act as a guide. Okay, and then there it is, the star down here at the bottom. It's going to take that as a guide, and then we're going to we're going to find ourselves pointing in a different direction. Let's go bring up our observatory view. Okay, the telescope appears like it's going to be fine. And there is a star pulling in the view over here. Right there, you just barely see it right there. Okay. Actually, I might actually have I want to change maybe some parameters here.
Isabella asks why this changes.
I will show you, Isabella. We should be able to take a quick 20-second photo of it, and then I can actually, I could have just gone into a 4K video mode and looked at it visually and then moved it into the center. Isabella, this is a reflection nebula, and this reflection nebula has at its I won't say center because that's not where it is, but it's a nebula that is right here, and I gotta just go longer here. Oh, I'm in the other filter too. I want to go to number 2. What happens is this reflection nebula has been often confused with the star that's near the middle of it, okay, or near its end. People think that that's where that's the star that's causing it to light up, and it's not. That was research done at a later point that pointed that out. So let me just pull it up more into the view here, and then, well, now it's right about here. I'll do a 25-second shot after I get my guide star, which should be just about now. Okay, and when I show you the picture, I'll explain how it actually works. Because what's happening is there's a star that you can't see that's illuminating it, and that star may have a dark cloud of dust that's orbiting it, and as that cloud of dust orbits the star over a period of days, then it changes the light cast onto this nebula, and thus changes the brightness of the nebula. So here is the nebula right here. Okay, this is Hubble's Variable Nebula, and let's just go into an all-screen view. So now when we look at this guy, right, you can see that this area right here, this star, you think that's the guy that's causing this thing to light up, and it's not true. Okay, the star causing it to light up is inside here. You say, well, wait, that's just empty space. No, it's not. This is a dark nebula. This is part of a giant molecular cloud. Okay, and this molecular cloud has this little area here that's showing up because there's a star inside here that's lighting that up from inside. But you're seeing the fringe being lit up, and this star just happens to be in the field, in the area. But it's not lighting up this nebula. Okay, the star doing it is not visible to your eye. It's inside. Which is why this sort of looks straight. It's because it's a dark nebula there, and there's stuff behind there. A deeper photo will show more complexity going on in here than you can imagine. It's really, really cool. Hey there, how you doing?
Can you excuse me for a moment, please?
Sure thing, Daryl.
Meanwhile, Genghis Khan wants to know what does the red tell us other than hydrogen?
In a nebula?
I'm assuming so.
Okay, well, that tells us something about the temperature of the stars, because a star has to be a certain temperature to ionize and cause a nebula or the gas to glow. Okay, like this right here, there's no gas glowing here. This is a reflection nebula. It's absorbing the light from the star and scattering the blue light, which is the high frequency light, which is the color here. You don't see any red here. Okay, and it's because of that. It's just scattering this light that you see here. It's not actually doing anything with the hydrogen gas. There's undoubtedly hydrogen gas there, but gas doesn't reflect light. Gas doesn't scatter light like this. Dust scatters light. So this is what we're seeing is a scattering nebula that has been classically called a reflection nebula, which the terms they're not right, but you know what? That's in astronomy now. It's built in. So people run with it now, but that's just not a reflection. That's not a reflection. That's actually scattering going on in there, which is causing that to light up like that. So, you know, that's why that's doing what it's doing. It is pretty though, isn't it?
It is.
Yeah, and I look at this now and I say, that looks kind of about the same as what I saw the last time. You know, when I look at this now. So it looks like it's about the same. You know? So, I do find that the Hubble's Variable Nebula is just beautiful. And now, Mark, just one more, D'Antonio. I don't know. I just do this all the time.
Yeah, you do.
I do.
And we love it.
I love it too. I'm going to go to this next object now because this next object is fun. And as the Earth rotates, then I don't have to move the dome. So I'm just going to where the Earth's rotating to.
Oh, that's the best part.
Yeah. So now I'm heading to this next object, which we'll see, and only now will you see. Okay. So there's our alignment star, and it's going to disappear in a moment. Boom! And we'll see a little cluster of stars show up any minute now. And when those clusters of stars show up, well, actually they will if, yeah, they're down here. And I'll bring them up.
And Genghis Khan says, Mr. D'Antonio's neighborhood, it's a beautiful day in this nebula, a beautiful day to view with you.
Oh, that's great. Well,
yeah.
Thank you, neighbor.
Yeah.
That's real nice. Thank you, neighbor. Wow. You know, it's a beautiful universe to see, a beautiful nebula to show all of you.
You know, listen, work on those lyrics. What a perfect parody. That's great.
Yeah, that
Love
would
it.
just not be
Yeah.
fun. That might not work out too well.
Well, I don't know. It's pretty good.
Okay, so this guy now, I'll go 12,800 on this one. Because this is going to be, I believe, the Christmas tree cluster and nebula. We'll do 25 seconds. Let me make sure I got this. Let me make sure I got this here because I want to see.
Oh, you got it.
I don't know. Maybe. Maybe I did. Because there's another reflection nebula in this as well that shows up really, really blue. And let's see if we can see it. Well, does not look like I did. I did find something else though. Look at that.
Ho, ho, ho. What is that? Whoa.
That is another strange nebula. So that nebula has to be around here. So why did that not work? Or did it? And I'm looking at this.
What are we looking for now?
The Christmas tree cluster, and I ended up I ended up finding this, but I don't see the Christmas tree cluster. So maybe it's actually over there. So it could be. So let me just try. Go east, young man, not west. So yeah, that's what we'll do. One ping only.
Horace Greeley's ghost will haunt you tonight.
Okay, let's try this.
Wow.
I want to see what that was anyway. I really look forward to being in Arizona. Oh man, I cannot wait.
Bortle 3.
Bortle 3/4, yep.
God.
So it's right there. That's an odd little nebula. So if I find that, I'll know exactly where I am. But good luck. It could be that the... Oh, wait a minute. Oh, it found exactly what I was looking for. It didn't. It wasn't the Christmas tree cluster. It was IC 2169. See that right there? See that right
Yeah?
there? Okay, that's that right there.
Whoa.
It found exactly what I was looking for. I picked the wrong thing. Sorry, guys. I am dense at times. Here is the Christmas tree cluster right here. That's what I wanted to see. And now we'll go see it. Actually, I probably can just... I can probably just star hop down to it, but I'll just do it this way because I just love doing it this way.
Yeah, like
Stars
Tara
are
says, you're looking for a star in a haystack.
Yeah, a star in a haystack.
Yeah.
That's right. Do you know there's an observatory named Haystack Observatory?
Really?
There is. I had a friend who worked there.
Be darned.
Yeah, Haystack Observatory. Wasn't in a haystack. Okay, now we should see a cluster, and there we go. Now, here's the cluster right here. And the cluster just has to be moved northward a little bit. And we'll be able to, I meant southward. Move the telescope south a little bit. Okay, that's what I wanted to see before. I apologize for the rude object I showed you earlier.
Well, I don't know. What do you think, everybody? Should we forgive Mark?
It was quite
Please.
rude, that object.
Come on.
It didn't make
No.
itself obvious. It didn't wear a sign. What is wrong with these things? These nefarious nebulae, I'm telling you.
Failure to identify.
Yes, exactly. Pull over. Wish Marianne was here. Pull over that nebula.
Get out the taser.
Pull over that noisy, nefarious nebula.
Murky Mark. Should point out the Christmas tree is upside down. The bright star you see at the top is actually the base of the Christmas tree.
Yeah, there's the Christmas tree right there, see? And there's the bottom. There's no angel on top, though. After we take the picture, I'll set it right. Don't worry.
And the cone is just below it, isn't it?
Yes, it is. Yeah, and the Cone Nebula is right beneath these two little stars. You can see a hint of the red right there. Okay, and then you can see the blue nebula, the blue scattering or reflection nebula associated with the Christmas tree cluster right there. Right, and now what I'll do is to show it to you correctly is I'll flip it over, and there is the Christmas tree cluster. There's the Christmas tree. Jingle bells, Batman smells, Robin laid an egg. See, so there you go.
Ah, sing on.
Yeah. And the cone is actually the angel on the tree at the top.
Oh.
Yeah. So let me just flip that back the other way where it belongs so that next one comes in, you won't say, hey, what's that? That's what I'd say. All right. So what I'll do now is to make it more clear is I will go down to narrowband 1. Stars will disappear, and I will now pop it up to a minute and a half at 12,800, the same. Okay, and now let's watch what we get. It'll be very different. We're going to see a little bit more detail now. And let's go see if I can find something else. Ooh, I want to go see Brian. Let's go. I want to go now. Lost. I want to go now, Brian. Yes.
Hey, Stewie, get upstairs.
Leave me alone, fat man.
Fat man. Right.
Yes.
Tara says the Batmobile lost its wheels.
Oh, yeah, all on Christmas Day.
Yeah.
Gosh, the weird stuff we grew up with singing that made no sense, but we still did it anyway because it was cool.
You know,
Until
right?
it wasn't.
It's still cool. It's cool nostalgia.
Yeah, maybe.
We can't put our grown-up, overview on it. Yeah.
Yeah. No. Yes, sirree. So, that said, hello, ma'am. Oh, my hat has 2 layers. I didn't realize that. I pulled my hat off and it doesn't come off because there's another layer underneath it that's staying on.
Oh. All the more to keep you warm.
Hey, do you remember those Where's Waldo books? Where
Yes, of course.
Waldo
yeah.
was a striped guy, right? That striped character. Yeah. Okay, this one, this shot, I had to go longer, but you can still see the nebula there, and the Christmas tree nebula. It's really pretty. The cone would have to go longer, but there it is. You can see the core of it pretty interestingly. It's there, but anyway, I saw a very interesting shot. A guy dressed up as Waldo, exactly as Waldo. The hat, the round glasses, and the striped shirt.
Yeah.
And he photobombed people's pictures. Sometimes at a great distance. And you saw him like in that sneaky pose.
Yeah.
From far, far away. And so they're taking, like, one of these pictures I saw him in were wedding pictures. And he photobombs the wedding pictures like this. Like he's sneaking through the picture, but he's far away. He's not even in the wedding party. He's not even on the grounds. He's like in a field next to where they're doing the wedding pictures. And you see him way in the distance. It was like the photobomb of the century. The photographer's not seeing him. There's just, hilarious. Where's Waldo? I've actually always wanted to do that.
Yeah, well, of course.
I'd photobomb people's pictures as Waldo, like.
Yeah. Rockstar says he never found Waldo, and yeah.
Well,
so
it's okay, Rock. Waldo never found you either.
yeah. So right back at you. And Alex Braun says hi. He is in now.
Hey, Alex, how are you? Thanks for coming, Alex. Good to see you. I know the title said Jupiter and Saturn together. That was hours ago. About, oh my gosh, we've almost gone 5 hours.
Can you believe it?
It's 4 hours ago we actually had Saturn and Jupiter in the same view. My mistake. I should have.
Pretty dramatic, but what's great is people can watch the video on YouTube.
Yes.
And see it.
Oh.
Yeah.
Okay, so now let's see. Is there anything else that I want to look at? Well, of course there is. It never stops. And there's one more that I wanted to actually look at. But I think it's up here. Sorry, I went full screen here for a minute.
You are forgiven.
Thank you, Mommy.
Well, you're welcome, son.
Whoa. Pretty sickening.
Okay, we'll retract.
Yeah,
okay.
Scary.
Yeah. Okay.
All right, let me come back down here.
And Alex Bronze, wants to look at the Orion Nebula, but
Yes.
Yes.
Yeah, I know he does.
Mark, how much of Mesa could you fit in your field of view?
Mesa?
The 3-star little asterism at the top of Orion.
Oh, I don't know.
That has quite a ring and nebulosity around it, too.
We should see if we can figure it out, Daryl.
Well, you don't have to tonight. I know you were looking for something else.
Yeah, but that's okay.
That's the head of Orion.
Yes.
Mesa is actually the top star in that triangle.
Yeah.
As opposed to Mesa, Arizona.
Exactly. As opposed
And we're
to
not
Mesa,
opposed
Arizona.
to Mesa, Arizona, but
Not at all.
Right.
Actually, I'm quite fond of
Yes.
Mesa, Arizona.
Yeah.
Let's see here. So let's go back to this view, and
Well, you can see a stellarium there. They show the nebulosity. It's a rather large, diffuse cloud of it.
Yeah, but what I'm getting at is this is the view of the telescope right here.
Okay.
So you can see how much of it will fit in there when I go there. I could get these 3 stars in there. Which actually, we can try it and see what we get.
Yeah.
Let's find out.
The nebulosity might be too diffuse. I don't know.
Oh, I'm sure it is actually.
Just a thought.
No, that's a good thought. Let's go see. Telescope might be okay. You have to see. Hey, what's that star doing down there? Get out of here. Get out of here. Go. Get out of here. Don't you play with me. Go. Get out of here. Excuse me, folks. Get out. Oh, you're just going to sit there, are you? Oh, no, get away from me. All right, now I'm mad. Beat it. Yeah, I'm coming for you. I'm coming for you right now.
Be gone. Be gone.
That's it. You better run. Yeah, that's right. Yeah. Hey. What are you guys doing? Get out of here. Yes, you can become punchy from all this. But yeah, so let's turn off the telescope view. We don't want to see that. But these are 2 of the stars from Mesa. MEISSA. And I'm sure that if I move over, we'll see the others. Hold on 1 second. That's better. Okay.
Mesa is another one that. When I shot piggybacks of Orion, it showed up wonderfully. The nebulosity around it.
Really? Oh, the piggybacks, yeah. Those would, yeah. Let's see if I go to the west. Oh, maybe I gotta go a little more this way. Or if it's doing the same thing as before, then maybe this way. This might be what I'm looking for. I'm not sure. I am not sure, Daryl. I can see where we want to be. I know where we want to go. Did I pick that star or did I not go there? Alright.
Mm-hmm.
Maybe I didn't actually pick the star.
Pick a star, any star.
Pick a star, any star. It should just go to Mesa now. Okay, so the star is just out of view down below. It should come up. Here we are. Hello. I'm poking it with my pointer. Dink, 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 dink. Yes, that's the alignment. So it moves over, then it'll zip away and should go to Mesa. And Mesa should end up right about here.
Yeah, I would think you'd be able to see 3 stars in a row just below it, and then a brighter one a little farther down.
Yeah. So that's got to be Mesa right there.
A star that knows it's being observed, right?
I'm not sure. Let's hope not.
Right.
But I do think that's going to be Mesa right there, Daryl. And you're saying that now below Mesa, which is right here, we should see 3 stars, right?
Yep, and then that 4th one offset a little bit to the right.
Like this one here?
Yeah, what's that called? Hoka?
Heka? H-E-K-A.
Heka.
Well, let's find out if this is where we are, because I'll just move it up a little bit. Now, don't forget, we're on narrowband 1 right now. So let's go to narrowband 2. Okay, see, now stars are showing up.
There you go.
So if that's Mesa, then we should, yeah, see, we got a star right next to it. And then the 3 below are a little to the left of Mesa. So that's, I'm assuming it's this one, and is there another one down below this one?
I would think so.
Oh, did you see that? Did you see right there? There was a flash.
Whoa.
I saw something. It came and went so fast.
Yeah. That's
what
weird.
What would that be?
Well, I'll tell you what it could be. Since this is the live view, we could have all witnessed a very special event. This could have been one of two things.
Satellite?
It could have been a geosynchronous satellite that's rotating and got a sun glint, okay? Or we could have been witnessing a meteor coming directly at us. Oh!
Ouch.
Actually, but seriously, it could have been one of those two things. But you saw it right there, right? Mark the time, someone?
Wow.
Like 22, it was like 22 to 35 or so. And right next to Mesa, we saw that flash, and it was fairly slow. It wasn't like an instant flash, which is how I knew it wasn't an artifact. That was really cool. Yeah, there's the 3rd star, Daryl. So this is indeed Mesa. Okay, we'll do a minute and a half at 12,800, and we'll see what we get. It's probably not going to be what you think, but maybe it will. Look, another one. See that right there?
Oh,
I
missed
saw
it.
another one there a few seconds ago.
Yeah, right there.
Wow.
Yeah, it was to the left of Mesa.
Yeah, it was right here.
Uh-huh.
Yep.
You had one there maybe a minute ago.
Yeah, okay. I'm wondering if we're seeing the geosynchronous flashers now, and more likely what it is, because if you look at our latitude here, we're pretty high. We're at plus 55. I don't expect any geosynchronous birds out except on the equatorial plane. So, what was that?
Mhm.
Did you see that?
I
Oh,
didn't see-
doggone it again. I was looking at chat. I missed it. Shoot.
You know, I'm just going to stare at this for a minute. I'm going to take the... I can't take the picture because that freezes the image. There's another one. See
Could
that?
this
Right there.
couldn't be anything to do with the meteor shower that just peaked and
we would
ended?
know.
Yes, no?
No, unless they're all coming right at us and going to, like,
Yeah.
pummel my house.
No.
So here's what you do, folks. Just stare right around here and let your peripheral vision bring you to a different spot in the sky. Or scan and be lucky enough to find the spot. I'll move the pointer out of the way. Over there, see it?
Yep, saw it.
Missed it.
Huh. Well, this makes me think. I sent you that short video the other day of geostationary sats in Orion.
Yeah. But those
You
would be
can see them all.
on the equator, though.
Right.
This is not. We're 55 degrees up. This is almost, you know, we're beyond halfway to the pole.
Mm.
All right, so I've seen 4 or 5 flashers now in the last, I'd say 5 minutes, right?
Wow.
I've seen several.
Yeah.
Yeah, chat's seeing it too.
Okay, yeah. Guys, we're seeing some really cool things. Are they UFOs? Yeah, I don't know. And nothing's off the table. I mean, I don't leap to those conclusions right away. Most likely there's some junk we've put up there. But I am really curious to know what caused those flashes, especially that one at 10:35, right here next to Mesa. It came and it went, and it was long enough for it to, I could move my eyes to it and see it, and then it went away.
Kara
Question:
says
Are they
space fireflies. Okay.
Yeah.
What, Daryl? Sorry.
are they trending eastward to the left?
Ah.
Well, I was
mean,
thinking
you saw one there, and then it seemed like all the other ones have been moving over slowly toward the east.
but they were
Would
down
they be out of the frame of view now?
somewhere down here though. But you're right. I mean, could it have been the tumbler? Yeah, maybe I should have taken a long time exposure. Duh. We would have known.
Yeah, but who knew, you know?
Yeah. I'll take one now. So this image is frozen right now. So we won't be able to see it, but we'll see if there's a tumbler, we'll see it.
Serendipity. I just wanted to see Mesa.
Well, you got Mesa right there in front of you.
Yep.
This is great. I'm glad I kept my hat on. It's cold in my office now.
And while we're waiting, that little video I sent you, I think it was only like 7 seconds long, and it was a longer time exposure. But what looked like all the motion of the objects moving from right to left was actually the constellation moving left to right, wasn't it?
Oh, I see what you mean.
I mean, if they were imaging Orion, then they were tracking Orion, and the stationary satellites would have appeared to be moving right to left.
That's correct.
Yeah.
Yep. Because they'd be tracking and the satellites stay over the same spot. Okay. Telescopes following the stars, not the, and accounting for the rotation of the Earth.
Right.
Okay, I see. There's Mesa right there, the 3 stars. Let's go full screen. I don't see anything in there, Daryl. I don't see any satellites in there.
Yeah.
But man, I thought that was really interesting to see those things. Those are really cool. Those are flashers.
Wow.
And they do happen often, and I don't know often what they are. But you know what I'm gonna try now? You know what I'm gonna try.
Tara says it was tumbling space weeds.
Tumbleweeds in space?
Yeah, tumbleweeds in space.
So see what I'm doing, Daryl? I'm moving over enough to be able to catch a tumbler. So let's try right here. And
what we were saying was live video before.
Well, this is live too, but
yes.
So Mark, for those of us who don't know, what's the definition of a tumbler?
Oh, it's a satellite that, as it's going through its orbit, it might be a rocket body that boosted a satellite to a higher orbit, and in so doing, whatever momentum it had has since degraded, and it's just tumbling slowly in its orbit. And sometimes that catches the glint of the sun, and they do this so regularly that you can actually do timings from it and know exactly when it's going to flash again, just like the iridium flashers did. Okay?
Right, yes.
Okay, I don't see any here, Daryl. None in this shot. I mean, it was something I did want to see. I'll keep heading eastward, try one more. It's only doing 30 seconds, but let's try this. Okay, take this picture. I'm not getting, some of these might not be guaranteed to be tracking right because I'm just taking the picture as soon as I can. As soon as the telescope stabilizes, I take the picture.
Are you still shooting 1.5 minute exposures?
No, this is just 30 seconds now.
Okay.
Because I want to catch something if it's doing it. Actually, we should go down to the equator and just take a picture. We're likely to catch some geostationary birds.
Mm-hmm.
They're 17th magnitude typically. All right, so why don't we do that? Let's. And the easiest way to do that is to just go down to, let's see. Let's go down to Mintaka. Mintaka is not where I want to be either, is it? Hold on a sec. We want to get rid of this guy, bring up this guy. Yeah, okay. Mintaka is pretty close to the equator, yeah? So let's go there. We have Betelgeuse in the upper left of Orion, and if you look out your window to the right, you have Bellatrix, a beautiful blue giant in the upper right of Orion. And then as we fall down through the belt of Orion, we see on the far left, we see Alnatak, and then we have Alnilam, and then on the upper right we have Mintaka. All of these stars are young stars, and when Australopithecus afarensis, otherwise known as Lucy, was tooling around Olduvai Gorge on her feeble 2 legs, she would look up and see only 2 stars in the belt of Orion because one of them had not been born yet.
Wow.
That is true.
Puts it in incredible perspective.
Yes, it do. That doesn't look like Mintaka. Would it take us to the wrong star? It went to Mintaka first. That's not Mintaka, I don't think. Doesn't even look like a Mintaka.
I had the oddest dream. I was calling my son. This was about maybe like 3 weeks. I think I mentioned it. I think Tara commented on it. I was calling my son, and his name was Mintaka. I have no idea what that means.
Ah.
Yeah, strange, weird.
Daryl, what's the, do you know the origin of the name Mintaka?
The etymology, not offhand, but I can find out. Give me a moment.
All right. Because I got 2 screens, and they're both taken up by chat and broadcast software, Skype, live screen into the observatory, live screen of the observatory telescope. I've got 1, 2, 3, 4, 5 applications all running at the same time. Don't see any geosynchronous satellites in this view. Oh man. Daryl finds things, don't worry.
Yeah. Yeah, sometimes.
He
Strange
find
things.
everything. You ask Daryl, he tell you. He find.
Yeah, exactly.
He
Hello,
good, he
Daryl.
find everything.
Knock, knock. Who's there?
Tara.
Tara who?
Tara Bull.
Oh, my God. Territory.
Oh,
Damn.
terrible territory.
Wonderful. So, say, like Daryl Mason, like Mason jar, like when is a door not a door when it's a jar. I'm circling back to Tara's door. Okay. All right, forgive me. It's Friday. It's
Door
been a
not
long
a-
week.
I don't get that.
Yeah, okay. I don't know. Yeah.
Yeah, you're all right. Don't worry.
All right, thank you.
Everything's fine. Everything's fine.
Ginga says Taka. What was that? The kid, the cave kid from Land of the Lost.
No, that was Chaka. He was one of the Pakuni.
Oh,
Come on, don't
Chaka,
you know
right.
that?
Yeah, Adam Lorber corrects. That was Chaka.
Ota. Remember? Water?
Yeah. What a series.
Yes.
All I see for the meaning of the name is from the Arabic al-Mintaka, which
Yes.
means the belt, as it is the first star seen in that portion of the rising constellation Orion.
Okay.
Oh, well.
Well, there you go. Okay.
That settles it.
Yeah, he's right. Okay, I could not get the telescope to lock on because the dome is probably just in the way of this part of the dome is in the way of the guide scope. I can see from here, so it's not locking on. And that's the thing that happens with the dome. That's why it's going to get converted to a roll-off roof after with the other telescope.
Cool.
We're actually going to start with the wide-angle telescope in this observatory, work out all the kinks, get the mount built here, the computer system set up. I'll write the software for it. And then it's going to get moved to the dome out west. And then the next telescope, which I have behind me, gets mounted in here, and we actually go back to doing astronomy with the East Coast one as well.
Wow.
Yeah. So we'll have it all. He who dies with the most telescopes wins.
I always thought that.
Nah, that was a funny thing we used to say as kids with our astronomy club. He who dies with the most telescopes wins. No, he who dies with the most telescopes dies. He doesn't win.
Then,
what's he win?
Right.
I want to win
Somebody
life
wins.
again.
Yeah, exactly. But who gets the telescopes?
Yes, exactly. Okay, 30 seconds to 20,000 on the Orion Nebula after we get our guide star. So we got to wait 11 seconds. It is still your turn. Ding, 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 ding. It's Chaka, not Minchaka.
Right.
Genghis.
Hello. Not right.
Yeah, you
Adam
know.
Lorber tosses in a fun fact about Land of the Lost. They reused the dinosaur footage because it was so expensive to produce. Oh, I'm not surprised.
Yes,
Yep.
that's right. And they called the dinosaur Grumpy. And the Sleestack. And there were some famous actors that actually did cameos and played Sleestack.
Really? I did not know that.
Yes, look it up.
I will.
Famous actors that played Sleestack on Land of the Lost. Marshall, Will, and Holly on a routine expedition. There's something things that they never known. Oh, darn dome is in the way.
Yeah. Oh, shoot.
High in the rapids that toss their tiny raft. And plunge them over 1,000 feet below to the land of the lost.
Oh, God.
Remember that?
Yeah, I absolutely do. And it's so cool that you remember it and sing it. I love that.
Oh no!
It's
Idiot Savant.
There was a film. Within the last 10 years.
Will Smith, Will Ferrell.
Yeah.
He did Land of the Lost.
Pretty darn funny.
I watched it. It was fun.
Yeah.
The dome's in the way of this. That's why it was having trouble locating stuff. Ay. I'm sorry, guys.
Yeah. Tara says it's still pretty in pink.
That's right. David Schmidt and his big brother Chaka and his big brother Chewbacca.
Right. Says
Yeah,
Chaka Khan. No, not to be confused with Chaka Khan. No, please.
Chaka Khan.
Okay.
Chaka Khan. Remember that song?
Which one?
Chaka Khan. It started that way. Chaka Khan. Chaka
Oh,
Khan.
yeah. Yes. Late 70s, I want to say. Yeah. Somebody has put on YouTube, up all of the James Bond movies for free, no commercials. It's like, oh, please.
Which James Bond movies?
Yeah, well, I actually watched Dr.
Roger
No,
Moore?
I confess. Yeah.
Sean Connery?
Yeah, God.
Pierce
There's
Brosnan?
even a Daniel Craig. Yep.
Daniel Craig?
Yeah.
I thought he did a fair job as Bond, but you know what? I don't know. For me, the epitome was always Roger Moore. He was the guy.
Yeah, he had that suave thing. He had panache. He was sophisticated. Yeah.
Daryl, what do you say?
He was a clown. Roger Moore was a clown show. To me, Sean Connery is James Bond. I'm sorry, he always will be.
Well,
Yeah.
you should also. Who was the guy that they couldn't get Sean Connery or Roger Moore, and he played James Bond like in one intermediate one?
George Lazenby.
Yeah, right. Okay.
Really? I missed that.
Yeah. It was a horrible movie
Oh.
because it just wasn't James Bond, and you knew it, and it's like, oh, he's not right. I felt Sean Connery as Captain Ramius, so the Red October was probably one of his pivotal roles.
Oh.
One ping,
He was
one
amazing.
ping only.
Yes.
Yeah. Yeah. Okay.
If you like Roger Moore, he did what I thought was a good film. What was it called? Folks with two F's? Ffolkes.
Oh yeah.
Sort of a British mercenary type.
Oh.
It was actually a decent movie.
Huh.
Interesting. I'll seek that out.
And if I remember correctly, Roger Moore played the Saint before he ever played James Bond.
Yes, that's right.
He drove a 1800 what is it, a P1800 Volvo? The little fastback Volvo.
Okay.
Wow.
Back in the 60s.
Yeah. David Schmidt is thanking you, Daryl, in all caps.
Yes, but he's thanking him for, like, putting those movies into his head. Now he has to watch them.
That's right.
Well, you're welcome, I guess, David.
Yeah, it's a movie worm, right? Like an earworm. Oh, Ginga said The Man Who Would Be King. Oh my God, yes. If you haven't seen that, oh my God.
That Kipling story, and it was him and Michael Caine.
Yes, it's brilliant. Yes,
actually
brilliant.
One of the movies that I like are the movies that are I like those action movies, but movies that really mean the most are movies where it's one person up against something else for the entire movie. Spencer Tracy, The Old Man in the Sea.
Yes.
I don't know the actor's name, but Approaching the Beyond. That's actually a movie I worked on at the studio. That was
really
one man heading to Mars, and his ship is just breaking down in front of him. He's got all kinds of problems. I did a lot of the ship models for the movie and stuff, and they had a great artistic idea, but the execution was going to cause the movie to fail. And I spoke out in the production meeting, and Doug was there, Doug Trumbull, and Doug has me around because he calls me, jokes around, and says, "Oh, I'm his chief scientist," right? He wants to make sure that anything he's coming up with makes sense, right? So they come up with these ship designs, and imagine a ship it's a big cylinder like this, okay, and it's got another thing. It has an arm like this on it, and they have the ship just rotating around like this, okay. The ship stays like this, but this rotating arm goes around and around and around, kind of like a spoke that's spinning. And I said, but in space, that's gonna cause them to try and rotate around a common center. Oh no, won't. That's what the art guy was trying to tell me, because he had it settled. He wanted to have this cylinder with a long armature and another capsule that would spin around and around. Okay, and those would end up spinning like this together, not like this. This thing would not sit still. It would end up doing motion of its own. There'd be a common barycenter between them. I told him that very calmly and very scientifically. And the guy basically looked at me and he goes, "You know what? We have our design. We don't need your input."
Oh,
yeah.
Ouch.
And Doug was in that meeting, and he'd not said a word. And then he goes like this. He says, "If Mark says it's not going to work, it's not going to work. I suggest you listen to him." And everybody was quiet for about 10 seconds, no lie. And then the guy said to me, he goes, Tell me again why it might not work." And they changed the design of the ships based on that, and they put a counterweight so that it would actually do that. I said, I know how this can work. It'll be more interesting. We can add a counterweight to the opposite side of the ship, and that'll make sense. And Doug was like, I like the idea. And they're like, I like the idea. It's like, of course you like the idea, because Doug said he liked the idea. So it's crazy. It's hard dealing with American crews. They have these preconceived notions. It's really hard to break through that. Yeah. It's okay. Science.
I've heard it said that's why the movie Interstellar, which I have yet to see, was one of the few that seems to be, more on key, because they actually listen to the scientific advisors.
Kip Thorne, yeah. Kip Thorne was an advisor, and you know the story, Daryl. I sat with Kip for 3 hours, and I talked to him about black holes years and years ago. And we talked about information transfer between black holes and the observer. And without boring everybody out there, the bottom line is, Kip said your ship could disappear into a black hole, but before you go into the black hole, you can see your ship coming out of the opposing hole that's giving that information back, basically. You get information about your ship out before you even go in. And the math worked out like you could do it. And I was like, wow, that's fascinating, but it just seems so non-intuitive. He goes, it isn't intuitive at all, you know? And he goes, this is where he told Stephen Hawking, he said, I sent Stephen Hawking the article saying that this could happen, and he wrote me back saying, no, it can't happen, and here's why. And he writes back. So Stephen read my article again, and I read Stephen's article rebutting what I said, and I felt that he was right. Stephen was right. So I told him, yeah, you're right, Stephen. You're right. It can't happen. And Stephen Hawking said, actually, no, Kip, you're right. I think it can happen. I reread what you said, and I think you're right. So they swap positions. Okay.
Whoa.
And what's the moral of the story? The moral of the story is that even the greatest minds on the planet, aren't the be-all, end-all, right? And they know it. You know, that's why they check their egos at the door when they walk in the room, because they know that, you know, all this stuff can be thrown right out the door, as much as they might believe it. And you know, it's on. And see, that kind of stuff guides how I worked in astronomy. I realized that, you know, what I say isn't always right. I mean, I have ideas about what things are, but I'm understanding what other people have researched, right? I only know for sure my own research and the stuff I've done. But what about stars? And when I talked about reflection nebulae and all this, how do I know about that? Because other people have done studies, and I've read about them in the APJ, the Astrophysical Journal, or whatever. It doesn't mean that I have done the research. It means I'm understanding the research because I read the research. I'm a contemporary who reads the research, right? Well, it doesn't mean that I'm right all the time. And so, you know, guys like, when you hear guys like Thorne turn his whole idea backwards and all around, it gets all twisted around, and he's like happy about it, you realize, you know, you can't take yourself too seriously. You've really got to be open to all these things, which is why I started getting into all the stuff I'm into. So I think it's a really good
open
lesson.
exchange. That's the only way we grow.
Yeah. That's right. You can't be closed. You know, you really can't. You know, but that's so. That's really neither here nor there. So sorry about going down that path.
No. That's listen. We love that. Are you kidding? It's a path we all need to know about. It's the it's the backstory. It's the insider stuff.
Yeah, it is. It's pretty cool. Now I know the dome is facing there, so I do want to try looking at one more thing.
Just one more.
Just the one more, and I'm hoping we'll be able to see it down here. Oh, I gotta turn off this. Let's back this out here. Oh, there it is. Okay.
And Kathy Pernasek is in the room.
Hey, Kathy Pernasek, how are you? Dun, 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 dun. Yeah. Now, I tried to look at this last time. Yeah, we had a problem. I can't remember what the problem was. I think... Oh, I know. I think the computer actually in the dome had died. Okay, we're going to look at this. Goodbye, Orion. Get Orion out of there. There we go. Okay, so.
And here comes Martian Johansson. I'm
Martian
sorry,
Johansson.
Martian. And he asks, what's on the agenda for tonight? Well.
Where have you been, Martian? We've been looking at lots and lots and lots of stuff, Martian, including seeing Jupiter and Saturn in the same field of view earlier tonight. But right now, I'm just trying to find one last little thing. But I'm going to make sure that the telescope isn't having an issue with it. And I can see that it might be. Let's go see. Well, let's just do this. Let me just take a... Let's do a shot here of this. It might be down there.
And Fantasy Ecstasy says, hello, everyone.
Hey, Fantasy, what's happening? Okay.
Fantasy says, Jupiter, Saturn, Mars look amazing the past month. Yeah.
Yeah. did. We looked at them earlier tonight, and they were both together in the view. It looked just beautiful. Well, let's see if this is more like it.
May I inquire what you're looking for, or is it a surprise?
Well, I was trying to make it somewhat of a surprise, but...
Okay, well, my lips are sealed.
Well, they are because you don't know what I'm looking for yet, but I think I found it. So I just have to bring my camera up a little bit more.
You're not looking for M46, are you?
You ruined the surprise!
There, you see, it's mind reading.
Yeah, I know. You didn't really ruin the surprise. It was actually, again, I'm on narrowband 2. This is fine. Yeah, I like showing this because it really is a very, very special cluster, which you know.
Oh yeah. Well, when I saw you go to the lower left of Sirius, I kind of got the impression.
You would not be incorrect.
It's in Constellation Puppis, correct?
Yes, the poop deck.
Yep.
You're just laughing because I said poop.
Yeah. And deck. You're right.
Yeah.
Yeah.
Hey, that's where the captain stood.
Yeah, I know.
Right?
That's kind of bad idea. Martian, M46 is a cluster of stars that has a very strange object in it that doesn't belong there. Oh, beautiful. There it is.
Well, you got it.
Yeah. And that thing that doesn't belong there is this guy right here. Now, you might say, well, what is that? And what's it doing in my cluster? Who put a donut in my cluster? Well, what it is actually is the remains of a dead star, actually. This outer area here, these are the outer shell remains of the gas that was in the atmosphere of the star. And this is a cluster of very young stars. So this doesn't make sense being here because it shows a star that is billions of years old, whereas these are only some hundreds of millions of years old. So star clusters have stars that are all the same age. So what is going on? It was a real quandary until we could look at the distances to this planetary nebula, as we call it. So named because these objects appear to look like potential planets in a telescope. And the cluster of stars behind it. And the operative word is behind it. This star here and its shell of ejected material is about 2,000 light years away. So you're seeing it 2,000 years ago. The cluster behind it, however, is over 4,000 light years away. So this is just a line of sight coincidence, which is really one of the most fascinating things that we can actually see in the sky. I love seeing objects like this that just don't make any sense, and this is one of them. Let's see if we can get a better photo of that for you guys. I'm going to drop down, go to 8,000 actually. 25 seconds again. And see if we can get a nice, beautiful shot of a dark sky object. So we'll see the next one come in. It'll be right about we'll see about the right same size, but darker. Any second now, and zap, come on. There we go. Yeah, and you can see now in this cluster being 4,000 light years away, that's pretty distant. And so the cluster is actually a little bit reddened by stuff in interstellar space between us and it. And it's actually called interstellar reddening. And then this star, this little tiny white dot right there, you see that little white dot, incidentally, right there is a white dwarf, 2,000 light years away. So white dwarfs are really quite luminous for their size, and they give off a lot of radiation. And the white dwarf is so hot that it's ionizing the gas that it blew off from the star, okay, that blew off of the star, and after the rest of the star shrunk down to this white dwarf stage, that hot temperature, that hot radiation emanating from the star ionized a lot of the hydrogen gas out in this envelope, as we call it, causing it to glow. And that's what a planetary nebula is. Now, if we took a longer exposure, this planetary nebula would end up looking like it's in color. This ring is definitely blue, and there's a twinge of red around the outside, which looks really pretty. But I figured I would close with that because we've actually gone for 5 hours and 30 minutes tonight, folks. Wow! This is a record for us. I mean, I don't think we've gone longer than this. It's because we started early. And hey, I never ate my dinner.
Yeah.
I don't need it anyway.
What's that? Right, exactly.
All right, well, look, guys, thank you for coming to SkyTour Livestream tonight. Tomorrow, well, the next clear night, we'll be looking at Jupiter and Saturn. They're going to be close to each other for more than just the 21st. Obviously, you know, we saw both in the same field tonight, and it's the 18th, so we'll be able to do that. If it's clear tomorrow, we'll see it again. If it's clear the day after that, we'll see it again. 21st, we'll see it again. 23rd, we'll see it again. You know, so if it's clear, we'll see it again. All right, but I did want to stream it tonight while we could. All right. Well, I want to thank you guys for hanging out here. I want to thank you, Carol, for coming on. Daryl, thank you for coming.
Sure.
And you know, it's
anytime.
Always wonderful having you here. Daryl and Carol. Oh, Daryl and Carol, my other brother, Daryl and Carol.
You know,
don't go there.
I love it. No, it's great. It's cool.
Yeah.
Wow. And everybody saying goodnight in chat.
Yeah, thanks, guys.
It was fun tonight and great stream and such a gift, Mark. Thank you. So say we all.
Well, you were all just wonderful. So you kept me here tonight. I wouldn't have stayed as long as if you guys weren't interested in being here. All right, guys. I have to take my hat off. And actually, I got to go out and close up the observatory after I do all the shutdown.
We take our hats off to you, Mark, for this. This is amazing to be able to look up. It gives us, in this particular time on planet Earth, it gives us a perspective that is unique and needed.
All right. Well, thank you there, Carol. That's wonderful. And Carol can be found on Behind the Obsidian Curtain, Friday nights at 7 p.m. on KGRA.
Oh, thank you again.
KGRAradio.com, that is. And listen to Daryl and I and Amanda on SkyTour Radio Sunday nights from 8 p.m. to 10 p.m. Eastern Time. And
yes, the best.
Yes, we have a lot of good conversation, and you know, we talk more these days. Anyway, so in addition, I thought maybe it might be kind of fun to go through the closed down procedure if you wanted to see that.
Yeah, I love the sound of it.
Oh yeah, well we've got to. I think we'll have to have that closed down procedure. You guys can hear the music here. Okay, so that's done. Okay, we're closing down the control of the scope, and now I want to bring up. Go here and bring up this guy. This is the important guy. All right, so here now what we'll do is bring up the dome cam so you can see what's going on out there. The telescope now is looking where it's looking. What I want to do though is put it into a parked position so I could close the lid. All right, so what I'm going to do is use this software here and go into park. So I hit park, and it should say it's going to go into park, and off you'll see it start to move. There it goes. I can vaguely hear it. I don't know if you can hear it. Now that's the park position, and when it reaches the park position, the telescope is ready to be shut off. All right, and this here is my list of commands to start the telescope, I did all these things. And now to shut it off, now that I've done that, I can now actually shut the power off. And you'll watch in the dome, if you're watching the dome shot, you'll see that the dome is lit up in there. And when I hit this, you should see the dome get a little darker. Alright, that's the power going off on the telescope. Now I close the roof, which in Arizona makes sense. Here it doesn't make sense. Okay, so, alright, now you see closing the observatory. Now in Arizona, the roof will be going back on. And here the roof will be going back on when it's the roll-off roof. Okay, and then the last thing is to close the lid of the scope, which is now this. And there we go. Alright. And that's it. The lid's closed in the scope, and technically I could go to bed now if I didn't have to go out there and now physically close the dome, because the dome has really turned out to be quite a problem. I prefer to have a roll-off roof because I can set up a roll-off roof just so easy, you know. And this dome doesn't react well to technology. It's too wonky. It's too flexible. The dome is meant for someone who's going to be in the observatory and run it from inside the observatory. It's not meant for remote operation. So, in any case, that's it. Telescope is now shut down, and all I have to do now is go out there and close her up. I can shut this down now. Alright, and then this gets minimized, and that gets minimized, and that's it. We're done. And this is my desktop out there. Alright, guys. Thanks a lot for coming out. Say goodnight, Gracie. Very good, Daryl. Good night, Gracie. And I'll hope to see you guys again in the very next SkyTour LiveStream. And I'll let you know when that's going to be. See you later, guys. Thanks for coming.
Good night, everybody.
Good night, everybody. Take care.